Hello children, a warm good evening to all of you. So hope all are very excited for a science examination, right? Your English exam is finished. Now going to see the science exam within a few hours. So within these few hours, what we are going to do now? So here we are going to solve few questions which are mostly will be having a kind of panic situation, which are very easy, but at the same time we need some time to think about. Such kind of questions mostly from the PYQs, previous year board examination papers, we have brought for you to solve it. So without any delay, be active, stay focused, keep your notebook, pen, pencil, whatever is there in your hand, and start answering the questions as and when it comes on your screen. So without delaying, let us go for our first question. So first question on your screen is here. What is this? Wow, it's an assertion question. The color of aqueous solution of copper sulfate turns colorless when a piece of lead is added to it. Reason is lead is more reactive than copper and hence displaces copper from its salt solution. So question is from metals and non-metals. As we know that whenever a metal reactivity is taken, a high reactive metal displaces a low reactive metal, isn't it? Right. Let me see what is the answer here. Let me see who are all in the online. Yes, Nobin is here, Gayatri is here, Kirtan is here, Flame. Come on, what will be the answer for this? So color of aqueous solution of copper sulfate. As soon as the reaction is given, let us make it into an equation form. So equation form goes on like this. So copper sulfate solution. So CuSO4 reacting with lead. Lead is Pb. So what will be the answer? So here lead is more reactive than copper. So definitely lead will displace the copper. So lead displaces copper, sending out copper. So it is PbSO4 plus Cu. So reaction is possible. That means assertion is correct. Assertion is correct. And what about the reason? Lead is more reactive than copper. So what I usually say is, whenever assertion reason questions are being given, convert the assertion into a why question form. Why does color of the copper sulfate turns to colorless when a piece of lead is added? Because lead is displacing the copper. Lead is more reactive than copper. Is the statement sinking or not? Yes, it is sinking. That means reason is the explanation for assertion. That means what is the option here? So answer is option A. Option A, it is the correct explanation of assertion. Okay? I hope I am clear, right? Very good, Kirtan. Next, coming to the next question without delaying. We will go a little faster because I don't want to waste much of your time. Let us see. Write the balanced equation for a reaction that occurs when blue colored copper sulfate crystals are heated. This question was asked in the year 2023. 2023. What would be the answer for it? Blue colored copper sulfate. Whenever the word blue color is being mentioned, that means the question is related to water of crystallization. So here copper sulfate, what is the water of crystallization of copper sulfate? Can anybody tell me? What is the water of crystallization of copper sulfate? Come on, chat box. Yes, it is 5H2O. So copper sulfate is combined with the 5 water molecules. When you heat it, what is going to happen? What is the color of copper sulfate? As the saying, it is blue color, the royal blue color. Now when it is heated, it loses the color. It starts fading away and forms copper sulfate, and the remaining 5 water molecules are coming out and it becomes white, colorless. So that is the reaction. So when you balance, it is automatically CuSO4 5H2O gives rise to CuSO4 plus 5H2O. The reaction is balanced. Let us go for the next question. Sodium hydrogen carbonate. What is the formula for sodium hydrogen carbonate? It is also known as baking soda. So it is NaHCO3. Very good. NaHCO3. What happens when you heat it? What happens? So this is the process happening regarding your, or otherwise during the baking of food materials. So when you heat, what happens? It gets converted into Na2CO3 plus H2O plus CO2 gas. CO2 gas. So just try to balance it. So 2 sodium atoms are there. So 2 NaHCO3. Then what about the hydrogens? There are 2 hydrogens. Here also we have 2 hydrogens. And here CO3 and CO2 plus O. So 2 CO3. The equation is balanced. LHS is equal to RHS. So these are the 2 balanced chemical equations which was asked in 2023. Okay children, let us go for the next question. Yeah, identify the reducing agent of the following reactions. These are a little bit tricky here because normally when you see the NCERT textbook it is directly given, but in 2023 this question is asked. How do you identify the reducing agent? Here I would like to tell you the first equation is ammonia NH3 with 5 oxygen molecules gives 4 molecules of nitric oxide plus 6 molecules of water. So I will tell you a small trick. What is it? If you want, normally confusion comes between oxidizing agent and reducing agent. For this I would like to tell you one thing. Just check out which substance is adding oxygen. That means who is providing oxygen and who is taking that oxygen. And here if you observe, oxygen is there, O2. O2 is being provided to ammonia. Oxygen is being provided to ammonia. That means NH3 gets converted to NO. Here it is undergoing oxidation. Correct? When you are undergoing this oxidation, what is happening? One thing you have to remember, the substance oxidized is nothing but the reducing agent. Examination point of view tip. The substance which is getting oxidized is the substance which we call as a reducing agent, and the substance which is reduced is considered to be oxidizing agent. Substance reduced is an oxidizing agent and substance oxidized is reducing agent. According to that, ammonia becomes the reducing agent. Ammonia becomes the reducing agent. Am I clear, children? Let us go for the next point here. So next question goes on like this. So next question is H2O reacts with fluorine to form HF plus HOF. Here we are having 2 places of fluorines. Now how do you consider which one is getting reduced, which one is getting oxidized, and which is the oxidized reducing agent? Here one thing remember, here we can observe that fluorine, here it is getting converted into HF. That means for the fluorine, here or here we are adding hydrogen. That means fluorine is getting reduced. Am I clear? Fluorine is getting reduced. So it is the oxidizing agent, and then H2O becomes the reducing agent. H2O becomes the reducing agent. Now coming to the third equation, if you check Fe2O3 reacting with 3CO, in this what is the reducing agent? Forms Fe plus 3CO2. Here you observe Fe2O3, observe carefully children here, Fe2O3 getting converted to Fe, means Fe2O3 losing oxygen. Losing oxygen means it is getting reduced. So if this is getting reduced, definitely this will be a reducing agent. So Fe2O3, so CO becomes to CO2. So that is the reducing agent here, okay. So that is the answer here. So coming to the next question, H2 plus O2 gives rise to H2O. Gives rise to H2O. So here what happens? Hydrogen is getting oxidized and oxygen is getting reduced. Since hydrogen is getting oxidized, so hydrogen is the reducing agent. So these are the answers. Yes, very good. So in the first equation, ammonia is the reducing agent. In the second equation, water is reducing agent. In the third one, carbon monoxide. And in the fourth one, hydrogen. So these are the ways how to find out the reducing agent. Am I clear, children? I hope I am clear, right? Note down your notebooks very carefully. Then question number 5. Oh my God, very big question. Let us see. A saturated organic compound A. So remember, children, we will be having these kind of questions usually. So ABC questions or XYZ questions is common in our carbon compounds chapter. So how do you solve that question? An organic compound A belongs to the homologous series of alcohols. Alcohols means the combination will be ROH. It will be ROH. Alcohols, right? Next one. On heating A with concentrated sulfuric acid at 443. So what I say for you, photographic memory is very important. So as soon as you see the word concentrated sulfuric acid at 443 Kelvin, immediately your bulb should glow that it is conversion of alcohols into unsaturated hydrocarbons. Why? What is the logic behind it? Remember here, he has given sulfuric acid, and remember that sulfuric acid, concentrated sulfuric acid is a dehydrating agent. What is it? A dehydrating agent. That means it is there to remove the water molecules. So what is going to happen here? C2H5OH. Let me add a page. So C2H5OH in the presence of sulfuric acid, what is happening? Loses water molecule to form an unsaturated compound called ethene. CH2 double bond CH2. So that is the first part. Coming back to the question. So on heating A, so let us consider A as ethanol. Let us go back again. So now unsaturated compound is B with molecular mass 28 units. Whether check. So it is telling here B is telling 28 units. Whether this is correct or not. Normally what happens is it could be any alcohol. But he is telling here 28 units. Means so what would be the alkene? Is it ethene or something else? This is for your trial check. So you know that the atomic mass of carbon is 12, right? So here it is 28. So whenever there is a double bond, definitely there will be 2 carbons. Am I right or not? So 28 units is the total mass of the substance. And here he is telling each carbon is 12. So take 2 carbons, it is 24. So out of 28, 24 is confirmed. That means it is 100% sure that the compound does not contain more than 2 carbons. So you can be sure, this is only for a counter check. Equation actually is ethanol converting to ethene. But still, whether it is ethanol, whether propanol, he has not mentioned here. He just mentioned an organic compound with alcohol group. It can be any alcohol starting from ethanol, propanol, butanol, anything will be. But what is given there to check only, we are taking here 28 units into consideration. So when we take that, 24 is contributed by carbon. Remaining 4 units are with 4 hydrogens. So it is now clarified that the substance is ethene and A is ethanol. Let us go for the next point. So the compound B on addition of 1 mole of hydrogen. Here remember children, mole is not there for our syllabus, but still sometimes they will be asking, don't be panic, what is this mole? Nothing else in that. Mole means blindly go, consider it is one molecule. For your understanding, for the examination point of view, one molecule of hydrogen. So what is happening when we are adding one molecule of hydrogen in the presence of nickel? Remember children, here this is called as hydrogenation reaction. We are converting a unsaturated hydrocarbon into a saturated hydrocarbon. That means here second step, B CH2 double bond CH2 plus 1 mole of hydrogen in the place of nickel. You may be studying platinum in your exams, in your books. You may be studying about palladium. All these three are okay. Nickel, platinum, palladium. All these are least reactive elements. Since they are least reactive only, we are taking it here, or else they will interfere in the reaction. So least reactive elements. So what is happening here? These particular nickel, platinum, palladium will be adding this hydrogen in the place of an unsaturation. Means in the place of a double bond. Here we will cut it. And then these two hydrogen atoms will be added, one each, so that the substance will become into CH3 single bond CH3, which is a completely saturated hydrocarbon known as ethane. That is the second point. See here. So B on addition of hydrogen changes to hydrocarbon C. So this is B and this is C. Am I clear children? Next, what is the next part you see? Identify A by C. Already we identified A by C. Write the chemical equation showing the conversion of A into B. Already we shown it. What happens when compound C undergoes combustion? Compound C undergoing combustion. That's the next point. What is compound C? Ethane. Shall I make it as a condensed form into C2H6 instead of CH3 single bond CH3? Yes, I can. Combustion. What is combustion? Reaction in the presence of oxygen. So plus oxygen, we are burning. What is combustion? Burning a substance in the presence of oxygen. When you burn a substance, what is the product here? Remember children, hydrocarbons when you are burning, they will be giving you carbon dioxide, water along with heat and light. So CO2 plus water plus heat and light. Here there is one point to be noted down. Since I cannot discuss all the questions in this 1.5 hour, let me give you a hint now itself. This is a saturated hydrocarbon and here we have an unsaturated hydrocarbon. I am marking it like this here. This is unsaturated and this is a saturated. Now the point is, sometimes in the exam they may be asking you, how do you differentiate between saturate and unsaturated? Here there are two tests. Specifically they will be mentioning you physical test and chemical test. What is a physical test? What is a chemical test? Physical test means you need to check the behavior or the characteristic property when it is burning. Combustion means burning. When you are burning, if the flame is coming to blue color, if it is coming blue color flame, it is a saturated hydrocarbon. Whereas if it is giving you yellow flame, like a candle flame, candle yellow flame, that, or else when you burn a paper you get yellow flame, or burn some diesel, kerosene, you get yellow flame. If you get that yellow flame with a black soot, it is unsaturated hydrocarbon. I hope I am clear, right? If it is a blue flame, it is saturated. If it is yellow flame with a black soot, it is unsaturated. That is a physical test. Then what about a chemical test, my dear children? What is a chemical test to identify whether it is saturated or unsaturated? It is nothing but bromine water test. BROMINE. Bromine water test. It is a element which is in liquid state. The liquid non-metal is bromine. Here what do you identify? If it is added to a saturated hydrocarbon, you know that saturated hydrocarbon undergoes substitution only in the presence of sunlight. Otherwise Murphy reaction, no reaction will go on. So here, if you take a saturated hydrocarbon, bromine will never react and the color of the bromine remains as it is. Got the point? It will remain as is. Whereas, if you take an unsaturated hydrocarbon like ethene, propane, butene, ENE or YNE, alkenes or alkynes if you take, and if you add this bromine water, the color disappears. That means that bromine get added to the unsaturation. Got the point? So this is a point which I wanted to memorize you when we are taking this particular point. So that's about the test of the saturated and unsaturated hydrocarbons. Okay. Next one you see, state 1 industrial applications of hydrogenation reaction. Hydrogenation reaction, what is the application here? Can anybody tell me? Kirtan, I would like to correct you. Liquid non-metal is bromine and a solid is iodine. Iodine is available in form of crystals, my dear. Iodine is crystals, but not, okay, am I clear? So the bromine water is brownish color. So that brown color of bromine will be disappearing. Right. Okay. Next one you see, what is the example of hydrogenation reaction? We studied in the first chapter, rancidity. That rancidity happens for oils and fats. That rancidity can be avoided by hydrogenation. So we also call it as hydrogenation of fats. So industrial application is to convert these unsaturated fats into saturated fats by adding hydrogen. That is a industrial application. Am I clear, children? Last one you see, name the product obtained when compound A reacts with sodium. This reaction is regarding ethanol. Ethanol chemical reactions, if you see the first chemical reaction you can see, what is that? Ethanol, C2H5OH when treated with sodium metal forms sodium ethoxide, C2H5ONa plus hydrogen gas. How do you identify hydrogen gas? Hydrogen gas can be identified by the pop test. What is pop test? Remember children, pop test means the gas will be sent through soap solution. Don't simply write it puts off the fire with a pop sound, top. No. Mention very clearly, the gas will be sent through soap water, then soap bubbles come out. And these soap bubbles will be brought near to a burning splinter, where this burning splinter will put off this particular soap bubble with a pop sound, top, and then switches off the burning splinter. The force which is created from the bubble, that will be helping to put off the fire, because hydrogen basically is a non-supporter of combustion. Okay children, let us go for the next question here. So almost all metals combine with oxygen to form metal oxides, right? Yes, almost all, not all, okay. Metal with oxygen forms metal oxides. Metal oxides are generally basic in nature, yes, very good. Because these metal oxides with water forms metal hydroxides. So they are basic in nature. Now, but some metal oxides show both acidic as well as basic character. Show both basic as well as acidic character. Different metals show different reactivity with oxygen. Yes, this is all we can see in the metals and nonmetals chapter when we take page number 43 and 44. 43, 44, 42. All these three are three chemical reactions with oxygen, water and acids. There you can see reactivity is the second part of the reaction. Some react vigorously and some do not react at all. Now the question comes. This is something like a case-based question. An activity is given, some matter is given, and solve the question. What happens when copper is heated in air? Remember, generally we remember copper is a low reactive metal. You all know that. So normally people will be having that mindset that since it is low reactive, maybe it is not reacting. But don't forget that copper does not react with air. Copper does not react with air, but copper when heated, you are giving some energy externally, you are heating it. When you heat Cu, when you heat Cu plus oxygen on heating gives a black substance called copper oxide, black residue is formed, copper oxide. So what happens when copper heated in air? It is Cu plus O2 gives rise to 2Cu plus O2, 2CuO, right? Coming next one. Why are some metal oxide categorized as amphoteric? Give one example. He is already mentioning here. Sometimes what happens is, case study, if you read completely, answer is before you. So here it is already given that they are showing both basic and acidic. Amphi means dual. It is having both acidic and basic character. So it is considered as amphoteric oxide. Examples are what? Examples are, what are they? Zinc oxide and aluminum oxide. Zinc oxide and aluminum. So these two oxides are amphoteric. That means they can react with both acid and also base. Remember here, regarding acid, anybody can write. If it is a zinc oxide plus HCl, closing your eyes you can tell it is ZnCl2, zinc chloride plus water. Whereas if it is with NaOH, that is the textbook reaction, page number 20, you can see about zinc. Then 20, and if you go to the metals numbers, you understand ZnO plus NaOH gives us sodium zincate plus water. Sodium zincate plus water. So here if it is aluminum, sodium aluminate plus water. So that is the reaction. Now what is it here? Sodium oxide plus water gives rise to sodium hydroxide, NaOH, the same Al2O3 plus NaOH. So I told you already, NaAlO2 plus H2O. It is sodium aluminate. Sodium aluminate, NaAlO2. See children, last minute this is, I cannot be going very slowly. So I am going little faster so that I can cover maximum questions. So try to follow it. It is not the time of explanation, it is the time of recapitulation. Okay, right? Next question. Ore of mercury. See here, names are very important. What is the ore of iron? Hematite. What is the ore of zinc? Calamine. What is the ore of mercury? It is cinnabar. Cinna. Let me write here. Cinnabar. Cinnabar. What is the formula of it, cinnabar? Anybody? Yes, Nobin, very good, very good. What is the formula for cinnabar? Come on, yes, Shivan, very good. Pranav, very good, fantastic, marvelous, wonderful. Come on, come on, come on. Cinnabar, yes, mercuric sulfide, HGS, I got from Jagjit first. Right, very good, Sakshi, very good, very good. So, HGS is cinnabar. Regarding cinnabar, what is asked? State the form in which it is found. Obviously, it is solid state. Then, write the chemical equations along with the condition required for the reactions involved in the extraction of mercury from its ore. So, reactions must be photographic memory, my dear children. Should not forget. If you close your eyes, reaction must flow around you. Let us start the first one. So, let us start from mercuric sulfide. So, mercuric sulfide, since it is a sulfide ore, it is undergoing roasting, correct? HGS plus O2 on heating gives rise HGO plus SO2, mercuric oxide. We got HGO, first step. Second step is what? Reduction. Here we need to, even though you study 100 times also, 101 time, you get sometimes slipped off. And you will remember, reduction means with the carbon. Reduction means with the carbon. But here it is different. Here it is unique. Here it is separate. So mercuric oxide does not require any reducing agent. So it undergoes a simple heating. Remember this word? Simple heating to decompose into mercury plus oxygen. So this is the reactions involved for conversion of ore into the mercury, which is followed by electrolytic refining. Okay? When this is about mercury, I would also like you to remind about copper, because copper mostly people make a mistake. During examination point of view, you get panic and write something. After coming out for exam, you will be remembering. What is that? So copper, if you take Cu2S, this is also sulfide ore. So this also undergoes reaction with oxygen, it is heated, roasting, so gives you Cu2O plus SO2. I hope I'm clear, right? So undergoes roasting, Now, second one is what? Reduction. Moderate reactive metals with carbon we did. For mercury, simple heating. Whereas for copper, there is a important point. Remember that, note that, write it down, underline, box it. It is called as self-reduction, children. Self-reduction. What is this self-reduction, sir? Again, self-reduction means the ore itself is involving in reducing the oxide. What is it? The ore itself is involving in reducing the oxide. So it is Cu2O is the oxide which is formed, gets reduced with Cu2S. Yes, forms Cu, crude metal copper, plus sulfur dioxide again. So this is the crude metal. So this point normally we try to forget it, because this is something unique. It has to be remembered, but we take it out. So remember these 2 points. Definitely one of the points will be coming for examination in some way or the other. Either one of this. Okay, let us go for the next question, children. Right. Compound X, which is prepared from gypsum, acids and bases. My God. Acids and bases is also one more important chapter. Last year it was given for 9 marks. So this year how many marks is going to be given? Let us see. So compound X is prepared. X is prepared from gypsum. That means gypsum is giving rise to X, which has got a property of hardening. When you remember this, you come to a word called POP, Plaster of Paris. Plaster of Paris. What is the formula for gypsum? Come on, gypsum formula is calcium sulfate dihydrate. Calcium sulfate dihydrate. On heating. When you heat this, what happens? At 373 Kelvin. 373 Kelvin forms CaSO4 dot half H2O along with 1.5 H2O. So CaSO4 half H2O means POP, plaster of Paris, and 1.5 H2O. Sometimes what happens in the examination, they will give us MCQs. In MCQs, how they will give? Even this time also, when I have given for my students in examination, they got some people mistake. The question goes, okay, how many water molecules are released during this reaction? How many water molecules are released during this reaction? Option goes on like this. Observe, children, carefully. Option A is 3/2. Option B is 1/2. Option C is 1/2. Option D is 5/2. And they have given, what is right answer here? Come on, can anybody tell me? How many water molecules are released when one molecule of one molecule of gypsum is converted into POP? Come on, tell me, what are the options here? Option A 3/2, option B 1/2, option C 1/2, and option D is 5/2. Yes, see people, see, most of your eye will be towards 1.5. I bet, children, 90% of children who are not aware will be making this mistake of 1/2. People think it is only 1.5. But the answer is also 3/2. What is the improper fraction of 1/1.5? 1.5, if you convert into improper fraction, it converts into 3/2, right or not? So options, multiple answer, A and C is the answer. But do we look at that? We look at for the optional. We look at for the right option. MCQs, why the people miss is this is one more point. We look for right option. We don't look for the other options analysis. You saw ready-made 1.5 ticked. But what about the remaining options? Is there chance of getting 1/2 or not? We don't bother at all. If we are bothering that 1 mark where you are losing, that will not be lost. So answer is A and C. Okay, let us come to the question again. State the difference in chemical composition between baking soda and baking powder. This is one more important topic. Baking powder, baking soda. Baking powder is what? Baking soda is what? Baking soda is NaHCO3, children, whereas baking powder is NaHCO3 along with any edible acid. Let me take here tartaric acid for your convenience. So, if baking soda is combined with tartaric acid or any edible acid, we call it as baking powder. Why? Why do we need to add tartaric acid here? What is the role of tartaric acid? Remember children, we have seen the first question, NaHCO3 gives rise to Na2CO3, right? Yes or no? Yes. When we take here, let me write down here, NaHCO3, while you are heating, while you are baking, it gives rise to, decomposes to Na2CO3 plus H2O plus CO2. Here this is a basic salt. It is a basic salt. And this basic salt means, as we study in our lower classes, bases are bitter in taste. Don't taste and see, okay, it's very dangerous. Baking soda is washing soda. So washing soda should not be tasted at any cost. So this Na2CO3 is bitter in taste. And if you leave it as it is, the cakes or the pastries remain bitter. So we need to add tartaric acid. Mafi tartaric acid, Mafi sweetness. Tartaric acid, what it will do? It is acidic. And this is what? This is basic. So both will neutralize each other. And the bitterness will be gone. Appo kaikyam battum. Right or not? So we have to follow that. When we add sodium carbonate along with tartaric sodium bicarbonate with tartaric acid, it neutralizes the basic nature of sodium carbonate. Okay children, come on, next question. Yes, one more fantastic question. Remember very carefully, check out. Let me see who will give the right answer at the beginning, fast. Come on, quick. Yes, there are three pictures here. Observe the picture carefully. All are having 6 carbons. A hint I have given you. Consider the structures of the 3 cyclic carbon compounds A, B and C. A, which is the right option? Right option, what is the right option? First of all, it is A and C are isomers of hexane and B is benzene. How do you follow it? Come on. Tanishka, what is it? If they ask to write the formula, then we should only write the formula, or should we write the entire equation? For which question are you asking, Tanishka? Can you get a clarity? If it is for baking soda, you need to write the equation also. Whether they ask or not, just mention equation, nothing more false. Don't exaggerate it. Okay? Yes. What is the answer here? So before solving this question, let us write the molecular formula of all the 3 compounds. 6 carbons are there, so it is C6. How many hydrogens are there? Each carbon contains 2 hydrogens, so it is automatically C6H12. What about this one? It is also 6 carbons, but number of hydrogens how many? There are 1 hydrogen for each carbon. It is C6H6. So all the 6 contains again 6 carbons. A number of hydrogens you see here, 2 here, 2 here, 4, and remaining 4, 8. Does any 2 carbons sync together? Does any 2 compounds have same formula? No. So they cannot be isomers. If you observe from the far, I can see everywhere finding isomer. So here A and C are isomers. Isomer means they should have same molecular formula, but here all the 3 are different. So Mafi. So answer is wrong. Next B. A is an isomer of hexane. Hexane is a cyclic compound. It is a straight chain. Straight chain and also cyclic compounds cannot be linked up together like isomers, because straight chain and the cyclic compound, the difference is 2 hydrogens. So that is also a wrong statement. Come to C. A is a saturated cyclic hydrocarbon. Yes or no? Yes. B and C are unsaturated hydrocarbons. Yes or no? This also having unsaturation double bond. This also an unsaturation. So I can consider this as the right answer. Then D again. He is telling B and C are isomers. No. So once you see the molecular formula, your confusion will be off. Am I clear to all of you children? Yes. Answer is C. Very good, very good. MB_649. Who is that? Very good, beta. Sabira. Very good. Benil. Very good. Kirtan. Yes. Pranav. Very good, very good, very good. White mango. Very good. Right. So let us go for next question. 40 already. The following diagram. Yes. Superb question this also. Definitely always they are giving one question on refining of copper. So what is this refining of copper? And what is the right answer? Let me see. Which of the following statements is incorrect? Incorrect. Here mistake happens, children. We don't read the word completely incorrect. We read it is correct and we try it out. The impure metal from the anode dissolves into the electrolyte. Which is the right answer here? Come on. Which of the following statements is incorrect displacement? Come on, what is the right answer here? Come on, come on, come on, come on. The impure metal from the anode dissolves into the electrolyte, or the pure metal from the electrolyte is deposited on the cathode. Pure metal from the electrolyte deposited on the cathode. Correct statement. Insoluble impurity settled down at the bottom of the anode. Anode mud. This is also correct statement. On passing current through the electrolyte, the pure metal from the anode dissolves into the electrolyte. Listen carefully here. I did not read the first one completely. On passing the current through the electrolyte, the pure metal from the anode dissolves into the electrolyte. The impure metal from the anode dissolves into electrolyte. Which is the right answer? Impure metal dissolves. Pure metal not dissolving. Impure metal only dissolving. Pure metal there is nothing to dissolve, right? Pure metal nothing to dissolve. So answer is option D. Impure metal from the anode is coming out. Impure metal, when it comes only, it dissociates into copper ions and anode mud. Everybody will think that impure metal coming from the anode is wrong. No, impure metal only comes from. Pure metal does not come out. Pure metal as such will not come out into dissolving. So impure metal when it dissolves, the copper when it dissolves, the impure copper when it dissolves, it gives into anode mud and also pure copper ions. So this is correct answer. So what is the answer here? The impure metal is correct and option is D. Yes, Pranav, Basil now came to completion. Yes. Understood now? See, before explanation, before reading the question twice, most of you are answering option A. Now it is coming to B. See how it is? Depends upon the way how you analyze the question, children. Am I clear? This is the point where you need to think twice before you answer. Next question. Right. This already we have seen it. When 2 ml of sodium hydroxide. Come on, let me tell the answer fast. Come on, come on, come on, quick, quick, quick. Sodium hydroxide with the zinc. Page number 20 NCERT textbook. What is it? Uses to sodium zincate Na2ZnO2. Since it is Na2ZnO2, this is overruled and this is also overruled. One out of these is the answer. Which is the answer here? Come on. Here zinc will give hydrogen gas, whereas zinc oxide will give water. So this is also not the answer. Answer is option B. Answer is very good, option B. Hamza, kindly check, okay. D is giving you water, but the question is regarding metal. If it is metal, it gives hydrogen gas. If it is metal oxide, it gives water. Okay? Clear? Right. Very good, Gayatri. Very good, Zoya. Very good. Come on, come on, come on, come on. Zoya, just check, you have given D answer. Next one. Water of crystallization. This is a question regarding memory based question. Water of crystallization. Number of water molecules present in a compound. Number of water molecules present in a compound. Here we have a table. What is it? Iron sulfate. FeSO4 contains 7 water molecules. What is the color? Color is green. Copper sulfate contains 5 water molecules, pentahydrate. Here let me write down the suffix also. 7 water molecules, we call it as hepta. Here we call it as penta. And the color is blue. Blue. Calcium sulfate. Here there are 2 compounds. One is POP and one is gypsum. If it is gypsum, it is 2 water molecules gives gypsum. Whereas if it is half water molecule, it gives POP. Sodium carbonate, washing soda, 10 water molecules, decahydrate. Got the point? These are the common compounds which are having water of crystallization. Okay? What is the question here? The question is the compound having maximum number of water molecules. So maximum is given by option D, 10 water molecules. Okay? Maximum is given by decahydrate, 10 water molecules. Washing soda or sodium carbonate, decahydrate. Okay? Let us go for the next question. Very good, very good, very good. Next one. Again assertion reason. So assertion reason means what you have to remember? Y form. Convert the assertion into Y. Hydrogen gas is not evolved when zinc reacts with nitric acid. True or false? NCERT book is beside you. Take tuck. Page number 44. Second paragraph. Last line. See what is it? It is nothing but reaction of nitric acid with metals. Metals with nitric acid does not liberate hydrogen gas. Instead, it will give you water along with oxides of nitrogen. Why? Because here zinc, let me change the color, zinc along with nitric acid, HNO3. What is it giving you? As usual, metal salt. Zinc nitrate, ZnNO3 twice, plus it gives you hydrogen. Let me finish off, okay? Don't feel. Listen carefully, completely. It gives you hydrogen. Later, immediately, what happens? This nitric acid becomes active and it is acting as a strong oxidizing agent. HNO3 is a strong oxidizing agent. Certain points you have to memorize, children. Previously we have seen sulfuric acid. It is a dehydrating agent. Same way nitric acid is an oxidizing agent. If this one will oxidize what? It is oxidizing the hydrogen. Nitric acid is oxidizing the hydrogen to form water along with oxides of nitrogen. Basing on the concentration of the substance. Sometimes it gives NO2, sometimes it gives NO3, or sometimes it goes NO1, nitric oxide also. So remember this point, nobody will be asking you as equation. They will ask you what is the reason. Reason means here nitric acid is an strong oxidizing agent and it oxidizes hydrogen into water. Am I clear, children? So statement is does not evolve. True. Statement is true. Nitric acid oxidizes the hydrogen gas produced to produce water. It is also true. So it is obviously the reason. So answer is option A. I have not mentioned your options. You may ask A, B, C, D, what? It is standard ones. So I didn't wanted to increase the space here. I didn't mention the options for A, B, C, D options. नहीं दिया मैंने. Because you all know what is A, what is B, what is C, what is D. From 2 years, 9th and 10th, you are already assertion reason. A is explanation, B not explanation, C A true or false, D A false or true. That is standard. Anywhere you go. So it is option A. It is an explanation. It is an explanation. For your sake, I am writing here an explanation of assertion. Okay, children, right? Next question you see, all of you. Come on, yes. pH of a tomato juice is 4.6. Oh, 4.6 is acidic or basic? Obviously, it is acidic, sir. How is this juice likely to be in taste? I told you previously also, acids and bases should not be tasted. It can only be predicted by the value. So here the pH is 4.6, means it is less than 7 acidic, so it is sour in taste. Sour in taste. Give reason. Because acids are mostly sour in taste. Right? They are acidic in nature. So that is the answer. Acidic in nature, so it is tasting you sour. How do we differentiate between a strong acid and a weak acid? Yeah, this is another important question, children. Make a star mark here. How do we differentiate between strong acid and weak base in terms of ion formation? Ions means either H plus or OH minus. What do you say? More H plus ions, it is less the pH and strong the acid, strong the acidic nature. So how do you differentiate? If it is a strong acid, means the pH value will be less because concentration of H plus ions is more. What about a weak base? Weak base will be having again less OH minus ions. Less the OH minus ions, less the OH minus ions, more, sorry, less the pH. And it will be a weak acid. Sorry, weak base. Weak base. So less OH minus ion, which gives you less number of OH minus ions, is a weak base, which gives you more number of H plus ions, is a strong acid. So this is the concentration of ions. Am I clear, children, all of you? That is how. Next one, you see the next question. The acid rain can make the survival of aquatic animals difficult. Yes, because when acid rain is coming, the pH value of the water is going down. Automatically water salinity is changing. Automatically water becomes acidic and becomes difficult for survival. So acid rains will be differentiating the life of aquatic animals. So got the point? That's about the question of pH. Next one, you see, define a homologous series of carbon compounds. Homologous series is one question which will be definitely coming as a either MCQ or somewhere 1 mark it will be asking. Homologous series means set of compounds. Yes, set of compounds with same what you call functional group which differ with CH2. Difference will be CH2. If the difference in the compounds, difference between set of compounds. Here I should mention one word, okay? Not simply said, consecutive. Let me add this prefix. Consecutive set of compounds will be CH2 or it is equal to 14 units. Why am I mentioning as 14 units? CH2 means 1 carbon 12 and 2 hydrogens 2. 12 plus 2, 14. So difference between set of compounds will be CH2. That is called as homologous series. Why is the melting point of C4H8 is higher than C3H6 or C2H4? A general question. There is nothing. We didn't study about this point. We didn't study about this point. But still, what is this point? So C4H8 contains how many carbons? 4 carbons. So bonds are more. 8 hydrogens. Obviously 8 bonds. So total number of bonds how many? It is more than this one. And we know that more the number of bonds, more the energy to break down. Am I right? Yes or no? More the number of bonds, more the energy to break down. So automatically more the energy, more is the melting point. Amount of energy to be supplied is proportional to the melting point of a substance or boiling point of a substance. So obviously automatically C4H8 will be having more melting and boiling point than the remaining two. I hope I am clear, right? Yes, more the bond, more the energy. Very good, Sabira. Very good, very good, very good. Yes, next one you see. Why do not we see any gradation, means differentiation, in the chemical properties of homologous? Why would we see? Gradation means differentiation. Why would we see? They all belong to same functional groups, my dear. If they are having same functional groups, they will behave also samely. Whether it is whether it is ethanol, propanol, butanol, oxidation gives you acid. Ethanol will give ethanoic acid, propanol will give propanoic acid, butanol will give butanoic acid. Right? Same way, reduction, you see, with sulfuric acid, you see, ethanol will give ethene, propanol will give propene, butanol will give butane. Same, chemical properties will not change. So, since they belong to the same family of compounds, the properties will remain the same. There is no gradation. Right? Next one is write the name and structure of. Yes, this is one more question we have to observe. Normally nowadays this is giving. They will give you a random formula which you never seen in your textbook, and you will ask you to find out the compound from that. For example, they have given which is an aldehyde and ketone. C3H6O. He is mentioning aldehyde. What is the functional group of aldehyde, beta? It is CHO. So subtract C3H6O minus CHO. So here there is 1 carbon, here 3 carbon. Reduce, becomes to 2 carbons. 6 carbon, sorry, 6 hydrogen. 6 hydrogen minus 1 hydrogen, 5 hydrogens. Oxygen is already removed. So it is C2H5CHO. Propanol. Propanol aldehyde. Come this side. Ketone. What is the functional group of ketone? C double bond O. Remove from that. C3 minus 1. C2. 6 hydrogens as usual. C2H6. It is a ketone. Make into 2 carbons. 1 carbon, 1 carbon. For a ketone, both the sides we will be having carbons. So each carbon valence is 3 here. Here also 3. Justified. Propanone. So there the question ends. Am I clear to all of you children? Am I clear children, all of you? Right. So next one will be, yes, I am getting reminder from the multimedia team. It is already 3 o'clock, sir. Let us finish off because one more teacher is waiting for the next session. Okay, let me finish the same one question. Okay, yeah, I got it, JD. Write the name and switch of organic compound X having 2 carbon atoms. So 2 carbon atoms. Group is OL, alcohol. It is ethanol, children. Ethanol. What happens when this? See. Here I just wanted to continue this question because only of one reason, because a question can be asked in any ways. If you observe, previously we saw in 2023, this is 2024. That means consecutively 2 years this question is being asked. I mean there are few questions which are being repeated constantly, and those points you cannot give a blank eye. You need to stress on that, need to revise it thoroughly so that these are repeatedly asking questions. So here it is 443 Kelvin. What does it give you? Ethene. Now here we are going to solve this one question, then I will take a leave from you. Electron dot structure of the hydrocarbon produced in the above reaction. What is the hydrocarbon? It is ethene. Electron dot structure C2H4. C2H4. So 2 carbons. So here what I tell is for you again an important tip. C2H4 electron dot, you will be confused. So always you do one thing. Draw a rough draft. C2H4. C double bond C H H H H. So convert it into, just take out the alphabets and place it here. Don't put the bonds. No sticks. Only alphabets. 1 carbon, second carbon. 1 hydrogen, second hydrogen. Third hydrogen, fourth hydrogen. 1 bond means 1 set of electrons. If I keep here dot, here also dot. Here also dot, here also dot. This is a bond, this is a bond. Khalas. Very simple. So simple like drinking water. Next, carbon and hydrogen. Carbon you are giving a dot, so hydrogen give a star. Carbon dot, again hydrogen star. Carbon dot, hydrogen star. Carbon dot, hydrogen star, and put bonds. Very good, finished. So they are saying you have done it. So like this. So beautiful. Just looking like a wow, correct? So this is about the structure of ethene. This is the product which is coming from ethanol on treatment with concentrated sulfuric acid at 443 Kelvin. Okay children, there are a few more questions. Let us also see it slowly. Okay, so let me finish off. So next subject will be very eagerly waiting. Until then, let me take a bye. So all the best for your exams. Do well. Success is only yours. Okay children, bye bye, take care.
Hello dear students, welcome back to the physics session of our last and final revision for your board examination. And without explaining much, I am entering into the first question. See, the first question here in physics part is the refractive index of a medium X with respect to Y is 2/3 and the refractive index of medium Y with respect to Z is 4/3. Calculate the refractive index of medium Z with respect to medium X. That is actually the question. See dear students, this is a refractive index related question. This is a very important question. Okay, that is refractive index is a very important question from very important area from chapter light reflection and refraction. You can see, look into the question first and you will have to write the given values. The refractive index of a medium X with respect to Y is 2/3. How can we write it? See, refractive index of medium X with respect to Y, that is Nx divided by Ny. Okay, refractive index of medium X with respect to medium Y, we can write it like this. This is equal to 2/3. That is given in the question. Okay, and similarly, what else is given in the question, dear students? The refractive index of medium Y with respect to Z is also given, that is 4 by 3. Okay, refractive index of medium Y with respect to medium Z. Okay, Ny by Nz is equal to 4 by 3. That is also given in the question, and we are asked to find out the refractive index of medium Z with respect to medium X. Okay, that is refractive index of medium Z with respect to medium X is asked to find. Okay, so see dear students, we got two equations here. Okay, two equations we got here from the question, that is this is the first equation and this is the second equation. Okay, so first equation is Nx by Ny is equal to 2 by 3 and second one is Ny by Nz is equal to 4 by 3. You will have to do one thing, you will have to simply multiply this both. Okay, multiply this both, that is first and second, multiply 1 and 2. Okay, if you are multiplying 1 and 2, we will be getting Nx by Ny into Ny by Nz is equal to 2 by 3 into 4 by 3, right? Okay, now you can cancel what? You can cancel Ny and Ny. What will be getting? Nx divided by Nz is equal to 2 into 4, 8 divided by 3 into 3 is 9. 8 by 9 is what? Nx divided by Nz. Okay, Nx by Nz is what? This is the refractive index of medium X with respect to Z, right? Okay, but what is the question? The question is, it is asked to find out the refractive index of medium Z with respect to medium X. Okay, what is refractive index of medium Z with respect to medium X? Refractive index of medium Z with respect to medium X can be written like this: Nzx, which is equal to Nz divided by Nx, right? Okay, Nx by Nz we know, which is 8 by 9. So Nz by Nx will be what? Which is equal to reciprocal of this, right? Okay, Nx by Nz is equal to 8 by 9. So Nz by Nx will be equal to 9 by 8. Okay, this is our answer. 9 by 8 will be the refractive index of medium Z with respect to medium X. Okay, yes. Okay, right. Now let us go to the next part of the question. If the speed of light in medium X is 3 into 10 to the power 8 meter per second, calculate the speed of light on medium Y. That is actually the second part of the question. Okay, so in the second part of the question, some values are given, that is speed of light in medium X. Okay, we can write it as Vx. Vx means what? Speed of light in medium X, which is equal to 3 into 10 raised to 8 meter per second, that is given. Now you see, we wanted to find out the speed of light in medium Y. Okay, speed of light in medium Y we wanted to find. See dear students, one equation we have written first initially, that is Nx by Ny. Okay, Nx by Ny, Nx by Ny is equal to, see, Nx by Ny is what? It is the refractive index of medium X with respect to medium Y, right? Okay, refractive index of medium X with respect to medium Y. Refractive index of medium X with respect to medium Y, how can we write in terms of speed of light? In terms of speed of light, I'll be able to write it as Vy by Vx, right? Okay, we know that speed of light is, inversely proportional to the refractive index of the medium. Okay, so Nx by Ny will be equal to Vy by Vx, that is refractive index. See, Nx and Vy is coming here, Ny and Vx is coming here, that is they are inversely proportional. Refractive index and speed of light is inversely proportional. Okay, Nx is equal to 1 by inversely proportional to Vx. Okay, right, so we can write it like this. Now substitute the values. Nx by Ny, we know what is Nx by Ny, which is 2 by 3. So we can write it like 2 by 3 is equal to Vy we wanted to calculate divided by Vx is given in the question, that is 3 into 10 raised to 8 meter per second. Okay, so what is actually Vy from this? Vy is equal to 2 into 3 into 10 raised to 8. Multiply this 3 into 10 raised to 8 into left hand side and divided by 3 also will be the 3 and 3 is cancelled, which is equal to 2 into 10 to the power 8 meter per second. Okay, so 2 into 10 to the power 8 meter per second is the speed of light in medium Y. Okay, see dear students, again I am telling you, refractive index, from that part you can expect one question at least. Okay, it may be either a numerical like this, otherwise it may be like, state the laws of refraction, maybe first law of refraction, and Snell's law of refraction is very important. Okay, what is Snell's law of refraction? Sin I divided by sin R is equal to N, which is the refractive index of the medium. Okay, that is ratio of sine of angle of incidence to the sine of angle of refraction will be a constant for a given pair of media and for a given color of light. Okay, this all you will have to remember related to the refractive index, and there are much more things. I hope all of you have revised everything. Okay, right. Let us go to the next question. Define electric power and write its SI unit. Electric power is actually another very important question. Directly it will ask to define electric power. Okay, what is the meaning of electric power? Electric power is nothing but it is the amount of energy. Okay, it is the amount of energy consumed by a device in 1 second. Okay, electric power is there for every devices, right? An air conditioner will be having its own electric power, maybe 1000 watt. Okay, 1000 watt means what? It is consuming 1000 joules of energy in 1 second, right? Okay, for example, suppose another device is having 50 watt power, it means that it is consuming 50 joules of energy in 1 second. Okay, that is what is the meaning of power. So power is nothing but it is the amount of energy consumed by a device in 1 second. Okay, that is what is the power, and its SI unit is what? Its SI unit is a watt. Okay, so 1 watt is equal to what? 1 watt is equal to 1 joule per second, right? Okay, 1 joule of energy is consuming in 1 second means the power is 1 watt. Okay, so definition of SI units are very important question. It may be for electric power, otherwise it may be for electric current or potential difference. Okay, so what is the SI unit of electric current? 1 ampere, right? 1 ampere is equal to 1 coulomb per second, right? 1 coulomb of charge is flowing in a conductor in 1 second, then we can say that the current is 1 ampere, right? And what is 1 volt potential difference? That is 1 joule per coulomb, right? Okay, that is 1 joule of work is done to move 1 coulomb of charge from one point to another point, then we can say that the potential difference between that 2 points is 1 volt. Okay, and similarly, what is 1 ohm? 1 ohm is equal to 1 volt per ampere. Okay, 1 volt per ampere means 1 ohm is the resistance when 1 ampere current flows through a circuit with the help of a potential difference of 1 volt. Okay, so these all definitions you will have to remember. These all are important. SI unit, define SI unit of power, define SI unit of electric current, define SI unit of potential difference, define SI unit of resistance. Okay, all these you can expect as questions. So here 2 bulbs rated 100 watts 220 volt and 60 watt 220 volt are connected in parallel to an electric mains of 220 volt. Find the current drawn by the bulbs from the mains. Okay, that is actually the question. So let us go for doing this. See, initially we will have to draw a circuit as per the question. We are having 2 bulbs which are connected in parallel. Okay, this is the first bulb and this is the second bulb. Both are connected in parallel across a potential difference, right? What is the potential difference? 220 volt is the potential difference, and this is suppose bulb 1, we can take it as B1, and its power rating is how much? 100 watts, 220 volt. Okay, and what is bulb 2's power rating? That is 60 watt and 220 volt is actually the power rating of bulb 2. Okay, right. Now you see, suppose dear students, total current that is taken from the mains is I, suppose. Okay, I is the total current that is taken from the mains, and what will happen for that current when it is reaching at the junction? Junction means here. No, this is the junction from where the electric current is splitting into 2. Okay, one part will go through this, one part will go through this. That is I1 will go through B1, I2 current will go through B2. Okay, now you see their power ratings are given. What is the meaning of power rating like 100 watt, 220 volt? Its meaning is when 220 volt potential difference is given for this bulb B1, it will consume a power of 100 watt. That is what is its meaning. Okay, when this B1 is getting a 220 volt potential difference, it will consume a power of 100 watt. See, B1 is getting 220 volt, right? Because 220 volt is connected in parallel to 60 watt bulb and 100 watt bulb. Okay, so both of the bulbs are getting 220 volt potential difference. So both of the bulbs will be working in this circuit as per its power rating. Okay, both of the bulbs will be consuming, B1 will consume 100 watt and B2 will consume 60 watt because both of the bulbs are getting 220 volt from this circuit. Okay, so we will be able to calculate I1 and I2, that is the current flowing through B1 and B2 separately. See, first we will take for the bulb B1. Okay, bulb B1 we will take it first. For bulb B1, what is the power? P1 we can take. Okay, that is 100 watt, and what is the potential difference? Potential difference is V is equal to 220 volt, right? Okay, now we will be able to write the equation for power. P is equal to V into I. This is the equation for power. Okay, we can take it as P1 is equal to V into I1 because there are two bulbs, right? Okay, so what is I1 from this? I1 is equal to P1 by V, that is equal to P1 is 100 watts divided by what potential difference is 220 volt, right? So 100 watt divided by 220 volt, if you are calculating, we will be getting 0.45 ampere. Okay, dear students, so I1 we got, that is 0.45 ampere we will be getting. And similarly for bulb B2 also we will have to calculate. Bulb B2, that is P2 is equal to 60 watt, no, and V is equal to 220 volt. Here also we can write P2 is equal to V into I2. Okay, now I2 is equal to what? P2 divided by V, which is equal to 60 watt divided by 220 volt, right, which is equal to, you know, we will be getting 0.27 ampere. Okay, you can calculate it and get. Now you see what is the total current from the mains is asked, so we will have to add both the currents. Okay, total current in the circuit is I, that is equal to I1 plus I2, that is 0.45 ampere. Okay, I1 is 0.45 ampere plus 0.27 ampere. Okay, if you are adding this, we will be getting 0.72 ampere, right? Okay, 0.72 ampere, that is a total current taken from the mains in this circuit. Yes, okay, yeah, someone are responding. Okay, so hope this question is clear to you. We will have to find out the current separately through each bulbs and we will have to add it. Okay, so that we will be getting the, you know, total current that is taken from the main battery. Okay, alright, see dear students, here in this question you can go for calculating the resistance from the power rating by using R is equal to V square by P, and that will be little lengthy calculation. Okay, so this is the most suitable equation here. P is equal to V into I, you can use, you know, then you will be obtaining the answer very easily. Okay, right, now let us go to the next question. Next question, dear students, VI graph for two wires A and B is shown in the figure. If we connect both the wires one by one to the same battery, which of the two will produce more heat per unit time? Okay, since it is an MCQ, I am, you know, asking you to put the correct option in the chat box. Okay, everyone, please, which option will be correct, do you think? But look into the graph also. Okay, one graph is also given here. Look into the graph, which is having more resistance you will have to find. Accordingly you will have to devise which one will be releasing more heat per unit time. Okay, B, yes, everyone is saying B, someone is saying A. Okay, let us have a look into this question. See dear students, one point that you will have to note down here is what, you know, one by one we are connecting. Okay, that is these two wires A and B, we are connecting one by one to the same battery. Okay, that is very important point here. Okay, one by one to the same battery. Okay, one by one to the same battery. What a battery is applying? A battery is applying potential difference. No, battery is applying potential difference. Okay, so one by one to the same battery means potential difference is same in both the cases. Okay, potential difference is same in both of the cases. Okay, if potential difference is constant, you will be able to use a, you know, formula for calculating the power. Okay, here you see what is asked to find. Which one will produce more heat per unit time? What is heat per unit time? Heat per unit time is what? Heat per unit time is nothing but power. No, heat is energy. Energy in unit time is what? Power, right? Okay, heat per unit time is power. What is the equation for power? P is equal to V square divided by R. No, P is equal to V square divided by R. That is the equation for power. Okay, so we are having two resistance wires here. Okay, the VI graph for both of these resistance wires are given in the question. Okay, now we will have to write the equation for power for both of these separately. First of all, we will write the power for A, power for resistance wire A, that is PA is equal to V square divided by R is the equation for a, you know, power in terms of potential difference and resistance. Okay, so PA is equal to V square divided by RA we can put. Okay, PA is equal to V square divided by RA. Now what is the power consumed by conductor B? That is PB is equal to V square divided by RB. Okay, Why do I am putting V only here? Because potential difference is same in both the cases. It is connected one by one to the same battery, no? Okay. So V, I don't want to put VA and VB. I'll be putting it as V itself. But RA and RB I'll be writing here. Okay. See, in both of these cases, numerator part is same only, right? Numerator part is same only. Denominator is different, right? How denominator is different? Because if you are looking into the slope of this graph, you can see slope of, graph A is more, right? Okay. This is VI graph also, right? In VI graph, if the slope is more, then more is the resistance. So I can say RA is greater than RB, right? Okay. RA is greater than RB. If RA is greater, that is this resistance is greater. Resistance is greater means what will happen for power? Power will decrease, no? Power will decrease, right? Okay. So if RA is greater than RB, I can say power of A, okay, will be less than, okay, power of B, okay, because RB is lesser. RB is lesser means V square by RB will be greater. We know that for common numerator, if denominator is smaller, then the total value will be larger, right? So since RB is smaller, PB will be larger, okay. So second option will be correct here. Everyone answered, yeah. Very few have answered on A, okay, but you will have to correct it. Next question, let us go to the next question. A narrow beam of PQ of white light is passing through a glass prism ABC as shown in the diagram. Okay, draw a ray diagram to show the emergent beam as it falls on the screen DE. Okay, you can see the screen there, right? Also write the phenomenon involved and its cause. Okay, using the second law of refraction, state which color of light must have the highest value of refractive index among 7 visible colors. Okay. See, dear students, all of you know the answer for this. Actually, dispersion is the process happening here, right? Dispersion is the process happening here. The diagram we can draw, diagram of dispersion we will be able to draw like this. This is the triangular glass prism to which, to one of the refracting surfaces, a beam of, otherwise a ray of white light is incidenting, okay? Now you see this white light is actually splitting into 7 colors, okay? That is, red light will be deviating least, okay, and you all know that the violet light is deviating the most, right? Okay, violet light is deviating the most, and all the other 5 colors will be there in between them, right? So if you are keeping a screen here, a white screen here, in which we will be getting here red and we will be getting here violet, and all the other 5 colors will be there in between them. It is actually in the order of their wavelength it is arranged, no? And what this arrangement or pattern will be called, that is what is a spectrum, right? Spectrum of white light. Spectrum of white light is the pattern or the band of 7 colors which is obtained, by executing dispersion phenomenon through a prism, right? Okay, that is what is a spectrum means. So white light is incidenting to one of the refracting surfaces of a glass prism, and from there it is getting splitted, okay, dispersion is happening. Now you see, if I am drawing a normal here, okay, if I am drawing a normal here, that normal will come like this, no, that normal will be coming like this. This is what is the normal, okay, right? Normal can be drawn like this, okay. Now if this is the normal, you see, we will be able to mark the angle of refraction. What is the angle of refraction? Angle of refraction is the angle between refracted ray and the normal, right? See, for red I will be marking the angle of refraction. For red, this is the angle of refraction, no, angle of refraction for red, I am writing RR, angle of refraction for red, okay. Now what is angle of refraction for violet? Angle of refraction for violet is this. Angle of refraction for violet is RR, you can see, okay. So angle of refraction for violet is smaller, right, because it is bending most. It is bending most towards a normal, okay. And similarly, red is bending least towards a normal, and thereby it will be possessing more angle of refraction, right, okay. So angle of refraction is different for different colors here. I have marked only the red and violet, but all the 7 colors will be possessing different angles of refraction, right, okay. Now see, I also will be there, that is, this is angle of incidence, okay, this is angle of incidence. Now you see, dear students, one question is asked here. Using second law of refraction, state which color of light must have highest value of refractive index among 7 visible colors. Okay, which color has highest refractive index for the glass prism? Okay, that is actually the question. So using second law of refraction, we will have to state it, right? What is second law of refraction? N is equal to sin I by sin R. This is actually second law of refraction, which is Snell's law of refraction. It is nothing else, Snell's law of refraction. Okay, n is equal to sin I by sin r, right? But you see, for all the colors, I is same here. For all the colors, I is same here. R are different, right? That is, angle of refraction is different. Okay. So we will be writing this for both the colors, both the extreme colors like red and violet. Like refractive index of red. Okay, refractive index of red is equal to sin I divided by sin RR. RR is the angle of refraction for red. And similarly for violet, I am writing NV is equal to sin I divided by sin R of violet. Okay, depending upon the angle, right? NR is equal to sin I by sin RR, angle of refraction for red color. NV is equal to sin I by sin RV. Okay. See, dear students, here the numerator is same, angle of incidence is same only for all the colors, right? But angle of refraction is different. No, angle of refraction is different. RR and RV are not the same. Okay. We can write what is the relationship between, what is the relationship means how it is related. RR and RV are related. RR, what is that? Angle of refraction for red color is greater than angle of refraction for violet color, right? Okay. So angle of refraction is more for red color, means what will happen for NR, refractive index of red color, that will decrease, right? Okay. NR will be, less than NV. Okay. Because angle of refraction, using angle of refraction we will be able to write it. Okay. Angle of refraction is more for red. Angle of refraction is more for red. So of course sine of angle of refraction also will be more for red, right? Okay, because when I increases, actually when R increases, sin R also will increase. No, okay, right? So sin R is more for red and thereby NR will be less for red. Sin R is less for violet and thereby NV is what it will be more, right? So we can write NR is less than NV. Okay, so this is actually the explanation asked in the second part of the question. Using Snell's law of refraction or using second law of refraction, we will have to find out which color has more refractive index. We found that violet color has more refractive index than red. Okay, because it is its angle of refraction is smaller here. Okay, so remember that. Next question, let us go to the next question. Name and state the rule to determine direction of force experienced by current carrying straight conductor placed in a uniform magnetic field which is perpendicular to it. Which is the rule? The rule that can be used to find the direction of force experienced by a current carrying conductor is Fleming's left hand rule, right? Okay. Fleming's left hand rule is the rule using which we will be able to find out the direction of force experienced by a current carrying conductor. Okay, what is Fleming's left hand rule? That is, the pointing finger, middle finger and thumb of our left hand has to be stretched mutually perpendicular to each other. Then the thumb is pointing the direction of force, pointing finger is pointing towards the direction of magnetic field, and our middle finger will be pointing towards the direction of current. Okay, what each fingers represent you will have to mention in the answer. Okay, so that is what is Fleming's left hand rule, which is used for that purpose. And second question, an alpha particle while passing through a magnetic field gets projected towards north. Okay, in which direction will an electron project when it passes through the same magnetic field? Okay, very easy question only, right? First case, what we are having, alpha particle. See, dear students, what is the charge of an alpha particle? Alpha particle is a particle that is having positive charge, right? Alpha particle is a positively charged particle, and which is experiencing a force in the north direction. Okay, which is experiencing a force towards north. Here actually we should know a concept that if the direction of electric current reverses, the direction of force experienced also will reverse, right? Okay, that is, if an alpha particle is experiencing a force towards north direction, see, electron is a negatively charged particle. Electron is a negatively charged particle which will produce a current in the direction opposite to the direction of flow of electron. For example, if electron is flowing towards west, the direction of current will be towards east. Okay, like that the direction of flow of current due to the electron will be opposite to the direction in which electron flows, right? So definitely direction of current will reverse if it is an electron, and thereby the direction of force also will reverse, right? Okay, so the direction of force experienced by the electron in the same magnetic field will be towards south only. Okay, towards south only. Okay, remember that. So remember that when we are reversing the direction of current, direction of force will reverse. When we are reversing the direction of a magnetic field also, the direction of force will reverse. Okay, remember that. Either by reversing direction of current or by reversing direction of magnetic field, direction of force will reverse. If both the direction of magnetic field and the current is reversed, then no change will happen for the direction of a force. The direction of force will be remaining same. Okay, so remember all those things. And seriously, next question. The power of lens is +5 diopter. What is the nature and focal length of this lens? Okay, first part we will do at first. The power of this is +5. P is equal to +5 diopter. Okay, since P is +5 diopter, we will be able to find out what the focal length, right? Okay, what is the equation for focal length? F is equal to 1 by power. That's all. Okay, 1 divided by 5. 1 divided by 5 is 0.2 meter. Okay, 0.2 meter. Okay, and which is equal to 20 centimeter, right? 0.2 meter will be equal to 20 centimeter. Now let us look into the next question, next part of the question. So we found the focal length, and what will be the nature of this lens? This lens is a converging lens or it is a convex lens, right? Okay, next part of the question is, at what distance from this lens should an object be placed so as to get its inverted image of the same size? Okay, see dear students, we will be getting an image which is inverted and same size as the size of the object when it is placed at a 2f1, no, in front of a convex lens, 2f1. Okay, so that diagram has to be drawn here. Okay, right, this is f1, 2f1, f2 and 2f2 will be there. Okay, we'll have to place the object where at 2f1 a ray of light comes parallel to the principal axis will go through f2, another ray of light that is passing through optical center will go undeviated. Okay, see, we'll be getting the image where at a 2f2, we'll be getting the image at a 2f2, dear students. Okay, so in this case we know this is the object distance. No, this is the object distance. We know the focal length of the lens, right? How much is the focal length of the lens? Focal length of the lens is this much, this, okay, that is 20 centimeter. We calculated, no, 20 centimeter. So the object has to be placed at a 40 centimeter. Okay, so the object has to be placed at 40 centimeter in front of the convex lens. Okay, in front of this convex lens to get an image with the same size, okay, which is inverted, real and inverted. Okay, right, let us go to the next question. Right, the near point of eye of a person is 50 centimeter. Find the nature and power of the corrective lens required by a person to enable him to see clearly the object kept at a 25 centimeter. Okay, right, so this is what kind of defect this person is suffering from. Can you tell me, dear students, what is the defect this person is suffering from? Yes, this person is suffering from what defect? Myopia or hypermetropia. The near point of the eye of a person is 50 centimeter. What is the meaning of that? This person is not able to see till 50 centimeter. Near point is 50 centimeter. What is a normal near point? Normal near point is a 25 centimeter, but this person is not able to see up to 50 centimeter, which means that he is suffering from hypermetropia, right? Okay, he is suffering from hypermetropia. Okay, right. So in hypermetropia, you know, this person's near point is 50 centimeter. He wanted to shift his near point from 50 to 25 centimeter. For that purpose, he will have to use a convex lens with the proper focal length. And how much is that focal length and power we will have to calculate. Okay, so in hypermetropia cases, we will be taking U as what? Minus 25 centimeter and V as minus 50 centimeter. Okay, minus 50 centimeter means minus near point of the hypermetropic eye. Okay, so remember that in hypermetropia, take U as minus 25 and V as minus near point of the hypermetropic eye. Okay, in myopia, you take U as negative infinity and V as negative far point of the myopic eye. Okay, like that U and V you will have to choose. Now you will have to calculate the focal length using lens formula. Okay, that is 1 by F is equal to 1 by V minus 1 by U. 1 by F is equal to 1 by V is minus 50 minus 1 by U is minus 25. Okay, so 1 by F is equal to 1 by minus 50 plus 1 by 25 will come. Okay, that is minus of 1 by minus 25 will become plus 1 by 25. So 1 by f is equal to what? Take the LCM of 50 and 25, it will be coming 50. 50 by minus 50 minus 1. Okay, minus 1 plus 2 will come. No, minus 1 plus 2 will come. Okay, so 1 by f is equal to minus 1 plus 2 1 by 50 and f is equal to 50 centimeter. Okay, so the focal length of the corrective convex lens will be 50 centimeter, and what will be the power of that? P is equal to, we can take it as 100 by f in centimeter. Okay, I am calculating power by using equation 100 by focal length in centimeter. Otherwise you can use 1 by focal length in meter also. Okay, so this is equal to 100 divided by focal length in centimeter is 50, which is equal to 100 divided by 50 is a 2 diopter. Okay, 2 diopter will be the power. Okay, right. So in this way we will be able to calculate. Let us go for next question. Find the ratio of resistances of two copper rods X and Y of lengths 30 centimeter and 10 centimeter respectively, and having radii 2 centimeter and 1 centimeter respectively. Okay, look into the question carefully, dears, and just try to do this. Find the ratio of resistances of two copper rods are there. Okay, two copper rods are there. So we will be taking first copper rod X we will take it first. Okay, copper rod X. What is its length? Copper rod X length is what? 30 centimeter. No, so we will be writing it as LX. Okay, length of copper rod X, which is equal to 30 centimeter. And what is the radius of copper rod X? That is 2 centimeter. So we will be writing it as RX. Okay, RX, radius of copper rod X is equal to 2 centimeter we will be writing. Now we wanted to find out the resistance of copper rod X. Okay, resistance of copper rod X. What is the resistance formula? R is equal to rho L divided by A. No, rho L divided by A. A can be written as pi R square, but this is for rod X, so I am writing LX and RX square. Okay, rho LX divided by pi RX square. Okay, now I will be able to write it as R. I can put it as RX, resistance of rod X. Okay, so RX is equal to, what is LX? 30. No, 30 rho I can put, 30 rho divided by RX is how much? 2. No, so RX square will be 4, right? So it will be coming 4 pi, right? Okay, 4 pi. I hope it's clear. The steps are clear to you, I hope. Okay, we will be writing the formula for Rx, resistance of rod X. Okay, rho Lx divided by pi Rx square. So Rx is equal to 30 rho divided by 4 pi will come, because small letter Rx square is a 2 square, which is a 4, right? Okay, see dear students, here we will be using this formula Rx is equal to rho Lx divided by pi Rx square, and we don't want to convert here from centimeter to meter actually. Okay, because when we are taking the ratio, that will get cancelled. Okay, so no need of conversion here from centimeter to meter, because everything is given in centimeter. When we are taking the ratio, those will get cancelled. Okay, don't worry. Now you see, we will have to go for calculating the resistance of copper rod Y. Copper rod Y. Okay, copper rod Y, what is Ly? Ly is equal to 10 centimeter, and what is Ry? Ry is equal to 1 centimeter. No, that is given in the question, 1 centimeter. Okay, length is 10 and radius is 1 centimeter. Now you see, we will have to find resistance of Y also, that is rho Ly divided by pi Ry square. Okay, pi Ry square, and this is equal to rho into Ly is 10. No, so I can write it as 10 rho divided by Ry is 1. So 1 into pi will come, which is pi only. Correct? Okay, Ry is 1 only. So 1 square is 1. 1 into pi is pi. Okay, we will be writing it like this. Now we will have to find the ratio of Rx and Ry. Rx by Ry is equal to, what is Rx, dear students? Rx is 30 rho divided by 4 pi. Okay, 30 rho divided by 4 pi whole divided by 10 rho divided by pi will come. Okay, what all things we can cancel? We can cancel rho and rho, we can cancel pi and pi, we can cancel. Now 30 and 10 we can cancel, we get 3. Okay, so Rx by Ry is what? Rx by Ry is equal to 3. Here 3 will be there and here 4 will be there. No, okay, that is 3 by 4 only, right? 3 by 4 only will be there. Okay, so this is the ratio. Rx by Ry is equal to 3 by 4. Yes, very good, very good. Many are responding. Now you see, look at the next question. A current of 500 milliampere flows in a series circuit containing an electric lamp and a conductor of 10 ohm when connected to 6 volt battery. Find the resistance of the electric lamp. Okay, another question. See, make an idea how to do this question. We will first draw a circuit diagram for this question. There is a conductor as well as a lamp. Okay, both are connected together to a potential difference of 6 volt, right? We have given the resistance of the conductor, that is 10 ohm. 10 ohm is the resistance of the conductor, and resistance of the lamp we will have to calculate. Okay, and the current in the circuit is given, that is 500 milliampere, right? 500 milliampere means how much ampere it is? 0.5 ampere. No, 500 divided by 1000. Okay, 0.5 ampere will be the current in the circuit. Okay, so current we know, potential difference we know, total resistance is what? 10 plus RL. RL has to be calculated, resistance of the lamp has to be calculated. Okay, so what is V? V is equal to I into R. Okay, V is equal to I into R. V is how much? 6. 6 is equal to I is how much? 0.5. What is the total resistance of the circuit? 10 is the resistance of the circuit, resistance of the conductor, and RL is also there. So 10 plus RL will come. Okay, so 6 is equal to 0.5. will be multiplying inside the bracket. 0.5 into 10 is 5 plus 0.5 into 0.5 into RL, right? Okay, so take 5 here, so it will become 6 minus 5, which is equal to 1 is equal to 0.5 RL, and RL is equal to what? 1 by 0.5, which is equal to 10 by 5, that is 2 ohm. Okay, so 2 ohm will be the resistance of the lamp. Okay, 2 ohm will be the resistance of the lamp. Yes, yes, Iksan is answering. Yes, very good, very good. Yeah, let us go to the next question. Yes, I hope it's clear for you, right? We will be taking the total resistance of the circuit, total potential difference, total current. Then we will be using the formula V is equal to I into R, which is Ohm's law. No, okay, which is Ohm's law. This is Ohm's law equation. Yes, okay. Let us go to the next question. What are the factors affecting force experienced by a current carrying conductor in a uniform magnetic field? Depends. Okay. What are the factors affecting force experienced by a current carrying conductor when it is placed in the uniform magnetic field? Okay, see, suppose we are having a uniform magnetic field like this. This is a uniform magnetic field in which a current carrying conductor, which is carrying current I, is placed. Okay, suppose the intensity of the magnetic field is B. Okay, B is the intensity or the strength of the magnetic field. Okay, now you see, the force experienced by this current carrying conductor, formula is F is equal to BIL sin theta. I hope you remember this formula, right? F is equal to BIL sin theta. What are the factors affecting force? B stands for magnetic field, I stands for current, L stands for length of the conductor, and theta stands for the angle between direction of current and the magnetic field. Okay, these all factors will be depending the amount of the force experienced by the current carrying conductor. Okay, what are the factors? Magnetic field, current, and length of the conductor. Okay, magnetic field, current, and length of the conductor, and also the angle between direction of current and magnetic field is also a factor that is depending. Okay, because when that angle changes, the amount of force experienced by the current carrying conductor will be changing. Okay, I will show you one example. See, this is the case in which the angle between direction of current and magnetic field is 90 degree. No, 90 degree. Okay, so how much is the force? F is equal to BIL sin 90 degree. Sin 90, we know that sin 90 degree is equal to 1. So the force will be BIL only. This is the maximum force this current carrying conductor can experience when it is placed in the magnetic field. Okay, and what is the minimum force? Minimum force it will be experiencing when it is placed parallel to the magnetic field. Okay, suppose this is the magnetic field, this is the magnetic field B, in which a current carrying conductor is placed parallel to the magnetic field. Okay, parallel to the magnetic field. This white one is actually the current carrying conductor, suppose. Now the direction of current as well as the direction of magnetic field is same. The angle between direction of current and magnetic field is 0 here. No, okay, so what is the force then? F is equal to BIL sin 0 degree. It will be sin 0 is 0, so F is equal to how much? 0 only. It doesn't experience any force. Okay, there is no use of getting a current carrying conductor and a magnetic field. It doesn't experience any force if it is placed parallel to the magnetic field. Okay, remember that maximum force will be experiencing when it is placed perpendicular to the magnetic field. Okay, if you are placing giving it some another angles like 60 degree, 30 degree and all, it will be experiencing different amount of the forces, okay, and all those things you will be studying in your higher classes. You will have to remember these two cases only, when it is placed parallel to the magnetic field and perpendicular to the magnetic field. Maximum force, minimum force, okay. And we are applying Fleming's left hand rule. Fleming's left hand rule we are applying in this case, because this is the case in which the current carrying conductor is placed perpendicular to the magnetic field and maximum force is experiencing, okay. So remember all these things. So that we already discussed, okay. Maximum and minimum, when it is experiencing, maximum force will be experiencing when it is placed perpendicular to the magnetic field. Minimum it will be experiencing when it is placed parallel to the magnetic field. Remember these things, okay. Let us go for next question. List 2 causes of hypermetropia. What are the causes of hypermetropia, dear students? Causes of hypermetropia and myopia. You will have to remember. Causes of hypermetropia is what? First cause is a shortening of eyeball, right? Okay, shortening of eyeball. And second cause is what? Second cause is a less curvature, okay, less curvature or power, okay, less curvature or power of eye lens, right? Otherwise we can say excessive focal length, okay, excessive focal length of eye lens, okay, excessive focal length of the eye lens. These are the this everything is one only, no, this everything is a one only, okay. Elongation of eyeball is the cause of myopia, okay, elongation of eyeball is the cause of myopia, remember, okay. Shortening of eyeball is the cause of hypermetropia, okay, right. Low converging power, yes, low converging power means low power, no, okay. Less power means low converging power. Low converging ability means less power for the lens, okay, which means excessive focal length. Less power means excessive focal length, right, okay, right. Now you see, draw a diagram showing hypermetropic eye. How can we draw a diagram for hypermetropic eye? See, first of all we will be drawing an eyeball, okay, and suppose this is the cornea, right, and we will be having our eye lens and a ray of light that is coming from a nearby object, okay, a ray of light that comes from a nearby object. From nearby object the light rays will be coming diverged, no, light rays will be coming diverged, and these light rays will be focusing at a point behind the retina, okay, here it will be forming the image. This is what? This is the near point of the normal eye, okay, that is 25 centimeter, okay, right. So this is the diagram for hypermetropia. The image is forming behind the retina. We wanted to shift the image, you know, exactly into the retina, okay. For that purpose what do? We will be placing a convex lens with the proper focal length and power in front of our eye lens, okay, or in front of our eye. So shall we draw the hypermetropia correction also? This is the diagram for hypermetropic eye. Now we will have to draw for the correction of hypermetropia. Myopia and hypermetropia are very important, dear students. Any one is a very sure question for the exam. Remember that, okay, right. We will be placing our eye convex lens and corrective convex lens, okay. Two lenses will be there. Now a diverging light ray will get converged slightly by the corrective convex lens, and after that the image will be shifted, you know, or image will be forming exactly on the retina, okay. So this is the diagram. We can draw a straight ray also that is passing through the optical center, which is going undeviated, okay. So this is the way in which we are correcting it, and we will be able to locate the near point of the hypermetropic eye in the same diagram, okay. Just extend these converging light rays by the corrective lens backside, so that it will be meeting at a point somewhere here, and this point is known as what? This point is known as near point of hypermetropic eye, okay, near point of hypermetropic eye. This point is what, dear students? This point is the near point of normal eye, okay, near point of normal eye, okay, right. So this person by using this convex lens, okay, by using this convex lens, his near point will be here, normal near point, okay. Now if he is not using this convex lens, that is corrective lens, if he is not using, his near point will be somewhere here, okay, which means that at that time this region he will not be able to see, This red marked region, you see, this red marked region he will not be able to see. Okay. See, less than the normal near point no one can see. Even a normal eye also cannot see, you know, less than normal near point. But a person who is affected with hypermetropia will not be able to see between the normal near point and the, you know, near point of the hypermetropic eye. Okay. Beyond that only he will be able to see, right? So remember all these things about hypermetropia. Myopia is also there, that also you will have to, you know, revise. List the factors on which the resistance of a uniform cylindrical conductor of a given material depends. Okay, what are the factors affecting the resistance of a uniform cylindrical conductor, dear students? Quickly tell me, what are the factors? Length of the conductor is the first factor. No, first factor is what? Length of the conductor. Okay, length of the conductor. What is the second? What is the second you know, factor? Second factor is a area of cross section. Area of a cross section. Okay, and what is the third factor, dear student? Third factor is, you know, temperature. Temperature is also affecting. Okay, temperature is there. And fourth factor is what, you know? Fourth factor is you know, the nature of the material. Okay, nature of the material. Okay, these all will be the factors affecting the resistance of a conductor. Resistance of a conductor, please remember that, resistance of a conductor. But resistivity does not depend upon the length and area of cross section. Resistivity will be depending upon only on the temperature and nature of material. Okay, temperature and nature of material are the only factors that is depending the resistivity. Resistivity. Okay, resistance means all these factors will come. Resistivity will be depending upon temperature and nature of material. Tell me what will happen for resistance and resistivity when the temperature increases for a conductor. When temperature increases, its resistivity or resistance will be increasing. Okay, okay. So remember that when temperature increases, you know, when temperature increases, resistance of a conductor also will be increasing. Okay, the mechanism is actually, you know, when the temperature increases, the electrons and the particles, okay, ions, electrons and all will be moving more faster inside the conductor, and thereby it will be undergoing for more number of collisions, and thereby resistance will be more. Okay, this mechanism and all will be studying again in 12th standard. Okay, don't worry. So just understand, when temperature increases, resistivity or resistance will be increasing for the conductor. Okay, right. Now you see, another usual question which is coming for the exam is how radius is depending the, you know, resistance of the conductor. When radius of a cylindrical conductor is doubled, when radius of a cylindrical conductor is halved. Okay, like that question you can expect. See, when radius of a cylindrical conductor is doubled, then what will happen for the resistance of the conductor? Can you tell me what will happen for the resistance of the conductor when its radius is doubled? See, what is the equation for radius? R is equal to rho L divided by pi r square. No, rho L divided by A. Rho L divided by A means rho L divided by pi r square. That's all. Okay, rho L divided by pi r square. This is the resistance of the conductor. Okay. Now you see, if the radius is doubled means R will become 2R. Radius is doubled means R will become 2R. Now what will be the new resistance? R dash we can take. R dash is equal to rho L divided by pi into 2R the whole square. No, pi into 2R the whole square. Okay, which is equal to rho L divided by okay, pi into 4R square. Okay, 4R square, which is equal to 1 by 4 into rho L divided by pi r square, which is equal to 1 by 4 into what is this? Rho L by r square, which was the resistance that we had before, you know, before we are doubling the radius. Okay, so 1 by 4 into r, that is r dash is equal to 1 by 4 times r. That is, when the radius of a conductor is doubled, the resistance of the conductor will decrease by 1 by 4 times. Okay, remember that. Now you see, if the radius or the diameter of the conductor is halved, okay, radius or diameter, when radius is doubled means diameter also will double. When radius is halved means diameter also will be halved, right? Okay, so this is happening when the radius is doubled. Okay, now when radius is halved, what will happen? The new resistance will be R dash is equal to rho L divided by pi into R by 2 the whole square will come. No, R by 2 halved. Okay, which is equal to rho L divided by pi r square divided by 4 will come, which is equal to 4 rho L divided by pi r square, which is equal to 4 into rho L by pi r square is R. So what will happen for the resistance? R dash will become 4 times R. Okay, that is, if the radius or the diameter of a conductor is reduced into half, means what will happen, you know, the resistance of the conductor will increase by 4 times, remember. Okay, right. So in this way also question can be expected. It is asked, previous year it is asked, what would happen for the resistance of a conductor if its radius is doubled, if its radius is halved. Otherwise diameter is doubled, diameter is halved, like that. Okay, so diameter is halved means the radius will be halved, right? Both are same only, remember that. Okay, now look at the next part of the question. Next part of the question. Okay, next part of the question is the resistance of a wire of 0.01, okay, 0.01 centimeter radius, okay, 0.01 centimeter radius is 10 ohm. If the resistivity of the material of the wire is 50 into 10 raised to minus 8 ohm meter, find the length of the wire. What are the values given? See dear students, what are the values given? Radius is given, which is equal to 0.01 centimeter, okay, which has to be converted into meter, right? How will you convert from centimeter to meter? Into divided by 100, no, divided by 100 to convert into meter. Divided by 100 means 10 to the power minus 2, no, this much meter, okay, and this is equal to, see, this I will be able to write as 1 into 10 raised to minus 4, right? 0.01 into 10 raised to minus 2. I am shifting the decimal point 2 position right, so I will have to change the power of 10. 10 to the power minus 2 has to be written as 10 to the power minus 4. Why did I do it? Is because in order to remove the decimal point, okay, so that our calculation will become easy. So 1 into 10 raised to minus 4, you know, meter will be the what, the radius of the conductor, and its resistance, you know, is given, that is 10 ohm. Okay, what else is given? The resistivity is also given. Resistivity is 50 into 10 raised to minus 8 ohm meter. Find the length of the wire. Okay, length of the wire has to be calculated. So which equation you will be using? R is equal to rho L divided by pi r square. Okay, we wanted to find L, right? So what is the equation for L? Take pi r square into left hand side, so it will become R into pi r square divided by rho will come, no, divided by rho will come. Okay, rho has to be taken into left hand side, so L will be equal to 10 into 22 by 7 into R is how much? R is 10 to the power minus 4, no, 10 to the power minus 1 into 10 to the power minus 4 means 10 to the power minus 4 only. 10 to the power minus 4 all to the power 2 whole divided by rho is how much? 50 into 10 raised to minus 8. Okay, 50 into 10 raised to minus 8. See dear students, 10 to the power minus 4 all to the power 2 is 10 to the power minus 8. So this 10 to the power minus 8 and this 10 to the power minus 8 is cancelled. Okay, now what is left here? L is equal to 10 into 22, 220. Okay, 220 divided by 7 whole divided by, you know, 50. Okay, 50 will be there, right? 0 0 cancel, so L will become 22. Okay, 22 divided by 7 into 5, 35 will come. Okay, 22 by 7 into 1 by 5 will come, that is 22 divided by 35. 22 divided by 35, if you are doing, you know, you will be getting 0.62. okay, 0.62 meter, you check it. Okay, 0.62 meters you will be getting. So this is the way in which we are finding the length of the wire. Okay, length of the wire. Yes, very good, very good. Many are responding. Ihsan is responding, Novin is responding, Zayan. Okay, very good, very good. Yes, let us go to the next question. Diagram shows lengthwise section of a current carrying solenoid. Okay, lengthwise section of a current carrying solenoid, that is just you know, we are taking a solenoid and we are taking the section, lengthwise section in the middle of a current carrying solenoid. Okay, right. Now, you know, cross mark, on cross mark you can see this cross mark indicate current entering into the page, and this dot, encircled dot, indicates current emerging out of the page. Okay, decide which end of the solenoid, A or B, will behave as north pole. A or B is behaving as north pole, that is actually the question. Okay, give reason for your answer. Also draw field lines inside the solenoid, that is also we will have to draw. Okay, so see dear students, first of all we know one rule that we are using to find out the north pole and south pole in the circular coil, right? That was clock phase rule. If the direction of current is anti-clockwise, the pole will be north. If the direction of current is clockwise, the pole will be south, like that. Okay, I'll show you. See, suppose we are having a circular coil with us. Okay, suppose we are having a circular coil with us. This is a circular coil which is placed horizontally like this. Okay, a circular coil which is placed horizontally like this. Now suppose when you are viewing from the top, when you are viewing from the top, suppose you are seeing the direction of current. When you are viewing from the top, suppose you are seeing the direction of current as anti-clockwise. Okay, suppose you are having a circular coil like this. When you are viewing from the top, like this, you are seeing the direction of current as anti-clockwise. Okay. Now you see this, in this, how will you apply the right hand thumb rule? See, like this we will be applying, no, like this we will be applying the right hand thumb rule here, because in this arm the direction of current is towards right side. Okay, so we will have to apply the right hand rule like this here. Okay, so magnetic field lines will be there in between these. Okay, we can draw it like this. Okay, we can draw it like this. Can you tell me what will be the direction of a magnetic field inside the circular coil? See, the direction of current is towards right in this arm, so hold it like this. So inside the coil it will be the upward direction. No, inside the coil it will be in the upward direction. Okay, in the upward direction means inside the coil in the upward direction. Inside the coil the direction of magnetic field will be from where to where? From south to north. No, from south to north, right? We know that in a magnet, that is in a bar magnet, the direction of magnetic field inside the magnet is from south to north, outside it is from north to south. Okay, so inside the coil the direction of magnetic field will be from south to north. So this will be south and this will be north. Okay, see dear students, look into this. If the direction of current is anti-clockwise, if the direction of current is anti-clockwise, when you are viewing from one side, that side will be north. If the direction of electric current is clockwise, when you are viewing from one side, that side will be south. Okay, remember that. North anti-clockwise direction for the current, south clockwise direction for the current. Okay, remember that. Now you see, look into this diagram. See, look into this. So remember that north, what? North anti-clockwise. Okay, north anti-clockwise and south clockwise. Okay, south clockwise. Okay, remember that point. Now you see, look into this diagram. What is this point is actually a cross mark. Okay, this cross mark means magnetic field lines are going into the plane. It's given in the question. Cross mark, you see, cross mark indicates current entering into the page. Okay, into the page. And a dot, encircled dot indicates the current emerging out of the page. Okay, so we'll be just redrawing that diagram here. Okay, see, suppose this is the cross section. Okay, cross mark. Okay, cross mark. Okay, like that we'll be putting, and here we'll be having dot mark. Okay, dot marks will be there. Okay, dot. So lower side it is going out, coming out of the plane, out of the page. Upper side it is going into the page. Okay, like that we will have to draw the magnetic field lines. Okay, look at this. See dear students, on the top it is going into the plane. It is going into the plane, and you know, it is coming on the other side. Okay, it is coming on the other side, like dotted line I am putting, and at this point it is coming out of the plane. Okay, it's going into the plane, coming out of the plane, like this. Going into the plane, coming out of the plane, like this it is going. No, okay, so here it is going like this. Again it is going into the plane, here coming out of the plane. Okay, going into the plane, coming out of the plane. Okay, here out of the plane, again going into the plane at this point, coming out of the plane through this point, again going into the plane at this point. Okay, like this it is going. Now you see, if you are looking from, this is A, no, this is A. Okay, right, this is A. When you are looking from region A, what is the direction you are seeing for the current, clockwise or anti-clockwise? When you are looking from A side, clockwise or anti-clockwise? Anti-clockwise, no. That is at a point, at this point is going into the page, into the plane. Okay, it's going like this it is going. Okay, so here it is anti-clockwise. A, it is anti-clockwise. No, A is anti-clockwise. So A is anti-clockwise means A will be which pole? A will be north pole. No, A will be north pole. Okay, when you are viewing from B side, you can see the direction of current is clockwise. Okay, clockwise. So this will be which pole? South pole. Okay, so A will be north and B will be south. Remember that anti-clockwise direction for the current, the pole will be, you know, north, and clockwise direction of the current, the pole will be south. Now we will have to mark the, you know what, we will have to draw the magnetic field lines also. Okay, magnetic field lines also we will have to draw. That is inside the solenoid, magnetic field lines will be like this. we know that inside the solenoid magnetic field lines will be going from south to north, no, exactly similar to the magnetic field, okay, and outside the solenoid it will be like this, it will be from north pole to the south pole, like that we will be able to draw the magnetic field also, okay, right. Okay, see, last question we will do. Okay, last question. See, dear students, effective resistance of the circuit. How will you calculate the effective resistance of this circuit? What is the first step? R3 and R4 are in series. No, current is starting from here, current is coming here. Okay, I is the current flowing through R5. At this point, current is splitting into I1 and I2. Okay, I1 is the current flowing through 10 ohm, I2 is the current flowing through R4 as well as R3. Okay, now from here it is coming as I only, right? No current will be flowing through voltmeter. Voltmeter is a high resistance device. No, okay, so the full I will be flowing through 5 ohm. So what is the effective resistance? Quickly, without writing all the steps, I am quickly saying, but for the examination you will have to write all the steps, like R3 and R4 are in series, then the effective resistance will be 10 ohm. Okay, then that 10 ohm is in parallel with this R2. 10 and 10 in parallel means 5. Okay, then this entire 5 is in series with this 10 and this 5. Okay, so total, you know, 5 plus 10, 15, 15 plus 5, 20 ohm will be the effective resistance. Okay, I hope you got the steps, but for the exam you will have to write all the steps one by one. Okay, after each step you will have to redraw the circuit diagram, like that you will have to do. Okay, so R equivalent, directly I am writing here 20 ohm is the R equivalent. Now current drawn from the battery is I is equal to V by R, that is V is how much? 20 volt divided by 20 ohm, which is equal to 1 ampere is the current. Okay, now see, dear students, if I am asking you what is the current flowing through this R5, how much is the current? 1 ampere. Okay, what is the current flowing through R2? 0.5 ampere, because you see R2 is 10 ohm, R3 plus R4 is also 10 ohm. So 1 ampere will equally split at this junction. Okay, 1 ampere will equally split at this junction means 0.5 will go through R2, another 0.5 will go through this R4 and R3. Okay, now the current flowing through R1 is also 1 ampere. Okay, so current flowing through each resistors we got. Now if I am asking you what is the potential difference across each resistors, see what is the potential difference across R5? V is equal to I into R. No, what is I through this R5? 1 ampere into what is resistance? 10, which is equal to 10 volt. Okay, right. Now what is the potential difference across R1? What is the current through R1? 1 ampere itself. So again V is equal to I into R, that is 1 ampere into 5 ohm, which is equal to 5 volt. Okay, so potential difference V across what? R1. Okay, V across R1 is equal to 5 volt. V across R5 is equal to 10 volt. Okay, now how much potential difference is left? 5 volt is left. Correct, total 20, no? So 10 plus 5, 15, 5 volt is left, which will appear across this combination. Okay, the combination of R2, R3 and R4. Okay, so tell me what is the potential difference across R2? What is the current through R2? Current through R2 is how much? See, dear students, current through R2 is how much? 0.5 ampere. No, 0.5 into 10. V is equal to I into R. 0.5 into 10. How much? 5 volt. No, 5 volt. Okay, so potential difference across R2 is 5 volt. Now what is the current flowing through R4? 0.5. 0.5 into 6. 0.5 into 6 is how much? 3 volt. No, 3 volt. So potential difference across R4 is equal to 3 volt. What is the current flowing through R3? 0.5 ampere. 0.5 ampere. 0.5 ampere into 4 is how much? 2 volt. No, 2 volt. So potential difference across R4 is potential difference across R4 is 3 volt. Potential difference across R3 is equal to 2 volt. No, 2 volt. Okay, so we calculated the potential difference across each resistors, current through each resistors. Okay, such a type of questions also you can expect. Combination of resistors is a very important area. Combination of resistors is a very important area. Okay, series and parallel, everything will be given mixed. Okay, mixed circuit. See, this whole question I have written in few steps only. Direct answer I have written. Okay, because you know biology class also has to be happened. Okay, so you will have to revise. Okay, these questions you might have come across in your preparations. Okay, we have done it in the offline classes. Many times we have done in the offline classes different varieties of different series, parallel circuit, combined circuit. Okay, many things we have done. Okay, right. So now the rest of the part you will have to work by yourself, okay, right? As we discussed in the meeting at 12:30 we had a meeting with our head of the department as well as our director, so you will have to follow all the instructions that you got and write the exam stress free, okay, with a stress free mind. You will have to go to the exam hall and you will have to be very confident, just to go through the questions, which questions you are finding easy, that you will have to attend at first, okay. First means just to go through all the questions, all the sections, okay, which section you are finding easy, that one question is asked by you in the 12:30 meeting, right? Okay, so what is a suggestion I wanted to give to you is, you will have to go through each section, which section you are more confident. Maybe you may be knowing most of the questions, okay, from section C, then start with the section C, okay. And if you are able to write all the question properly in MCQ, if you are 100% confident, you can start with that section, okay. Like that you will have to attend. So all the best, dear students, and biology session also we will be having, okay. Thank you.
Hello dears, welcome to this session of biology. Okay, let's do first question. See here, we have various steps in a food chain represent. Various steps in a food chain represent. Here we have option food web, trophic level, ecosystem, biomagnification. What is that called? Various steps. Yeah, it is trophic level. If you take the food pyramid, you know that there are various steps, right? Which are the steps? Here you can see producers, consumers, primary consumers, secondary consumers, tertiary consumers. So these transfer of energy through these levels are called trophic levels. Now here we can write T1, T2, T3, T4. Like each step represent, here it is a trophic level. What is it called? A trophic level. So the correct option is trophic level. So various steps in a food chain, that is called a trophic level. Now next question. See, the amount of energy that flows from one trophic level to another in a food chain is. See, what is the amount of energy that transferred from one trophic level to another trophic level? We have learnt that only 10% of energy is transferred from one trophic level to another trophic level. So, what is the correct option here? Yeah, very good. It is 10%. Only 10% of energy is transferred from one trophic level to another trophic level. Next question. See, the primary consumers are in a trophic level. See, we know in a trophic level, in a food pyramid if you draw, T1 producers, primary consumers, secondary consumers, tertiary consumers. Like that we are writing, right? See, the primary consumers are, primary consumers. Here we can write producers, primary consumers, secondary consumers, tertiary consumers. So, the primary consumers are, here primary consumers directly feed on producers, right? The primary consumers directly feed on producers. So, which category is coming under this? Yes, it is herbivores. The primary consumers are herbivores. Very good. Jagjit, yeah, very good. Srihari, yeah. Next question. Ozone forms by the combination of free oxygen atoms and oxygen molecules. How do free oxygen atoms form at higher level of the atmosphere? See how ozone forms at the higher level of atmosphere. See, we know that the oxygen molecule, okay, with the action of high ultraviolet radiation, high energy ultraviolet radiations, this oxygen molecule split into oxygen atoms. Okay, oxygen molecule split into oxygen atoms. These free oxygen atoms combine with this oxygen molecule to form O3, that is ozone. So here, what is the correct option? Here, by splitting molecular oxygen into free oxygen atoms in the presence of low energy UV radiations, by splitting molecular oxygen into free oxygen atom in the presence of high energy UV radiations, by the combination of two molecular oxygen in the presence of high energy UV radiations, by the combination of two free oxygen atom in the presence of low energy UV radiations. So, what is the correct option here? See, by splitting of molecular energy into free oxygen in the presence of low energy or at high energy, when the oxygen molecule split into oxygen atoms, see, in the presence of high energy UV radiation. So, the correct option is option B. Option B, by splitting molecular oxygen into free oxygen atom in the presence of high energy UV radiations. Okay, keep going. Very good. Next question. With regard to various food chains operating in an ecosystem, the man comes under which trophic level? See, we have learned that different trophic levels in a food pyramid, right? In a food pyramid, with different trophic levels we learned. The T1, T2, T3, T4, right? See, in different trophic level, man comes under which trophic level? Is it the producer or consumer or decomposer? Which category? Yes, we know that it is consumer. Man is coming under consumer. Okay, very good. Next question. See, in the following food chain, plants provide 500 joule of energy to rat. Now here we have a food chain. See the food chain. Plant, rats, snakes, hogs. Now here plants provide 500 joule of energy to rats. Okay, 500 joule of energy to rats. So rats are having 500 joule of energy. Now, how much energy will be available to hogs from snake? Now, we have to find out how much of energy will be there in hogs. We know that the 10% energy law, right? Only 10% is transferred to the next trophic level. So, when it comes like next, snakes will be getting 50 joule. And what about hogs? Okay, very good, very good. All are sending the correct answer. Very good. It is 5 joule. Hogs will be getting 5 joule. So, here they are getting 5 joule. The energy is the amount of energy from hogs to hogs. From snakes, it is 5 joule. Okay, very good. Now, next question. The following organisms form a food chain. Which of these will have the highest concentration of non-biodegradable chemicals? Here we have the phenomenon associated with it also. You have to mention, you have to name the phenomenon. Okay, now we have the food chain here. Insect, hog, grass, snake and a frog. So when you write in the proper way, the hog will be coming last, right? The hog will be coming last. Now, which of these have the highest amount of biodegradable chemicals? We know that when in the food chain, when it goes to higher trophic levels, in a food pyramid, in a trophic pyramid, we know that when it goes to higher trophic levels, the highest trophic level, the organisms in the highest trophic level will have the maximum amount of biodegradable non-biodegradable chemicals, right? What is that process called? That process is called biomagnification. Very good. It is biomagnification. So here, hog will be having the highest non-biodegradable, means here you can see highest concentration of non-biodegradable chemicals, and that process, that phenomenon is called biomagnification. Okay, biomagnification. And we know that this question is very, very important. What is biomagnification and the 10% energy law and this biomagnification? You can expect one question for the tomorrow's exam. For tomorrow's exam, you can expect one question from this biomagnification and the 10% energy law. Okay, now the next question. See, what is meant by the term biomass? What is meant by the term biomass? When you consider the ecosystem or environment, all the living organisms, plants, animal, all the living organisms that present in this environment is called biomass. The total amount of all the living organisms that is present in the ecosystem or environment, we can call it as biomass. Next question. Now, what are decomposers? List 2 important roles they play in the environment. What are decomposers? What are decomposers? Decomposers are a group of organisms which break down organic, that means dead bodies, dead organic matter into the dead organic matter. These decomposers convert the dead organic matter into its simpler forms, right? into simpler forms. Now, what is its importance in the environment? What is the importance of decomposers in the environment? We can write two very important things about decomposers. One is that which clean up the environment. The decomposers clean up the environment. You have seen that one question, that is aquarium will get you can see what is the difference between pond and aquarium. Aquarium, we need to change the water frequently. But in pond also these organisms are living and the water is very clear because of the presence of decomposers. Decomposers clean that environment where they are living. So the first, we can write the very important function of decomposers as they clean up their environment. Now, second, we can write the recycle. They recycle the things, the nutrients in the ecosystem. They recycle the nutrients, and then we can write recycle nutrients. Okay, these are the two important functions of decomposers. Now, next question. That now we can do chapter-wise some questions. Chapter-wise some questions like life process, like we have 5 chapters. Okay, now the first question here. In which of the following groups of organisms are food materials broken down outside the body and absorbed? Now we have listed this organism's name, right? Which of the organisms are involved when they break down the food materials outside their body? That is decomposers, right? Decomposers. And that is coming under this fungi. And which of these organisms, which of these groups of organisms comes under this? Yeah, that is yeast, mushroom and bread mold, that are coming under this decomposers, right? So yeast, bread mold and mushroom coming under this fungi category. So which of the following organisms, groups of organisms are food materials broken down outside the body? That are group of fungi. Here we can write yeast, mushroom and bread mold. Okay, next question. The contraction and expansion movement of the walls of food pipe is called. What is the contraction and expansion? The zigzag movement, we know the zigzag movement that happens in our alimentary canal. What is in the food pipe? The zigzag movement in the food pipe. What is that called? That is peristaltic movement, right? What is that called? That is peristaltic movement. Very good. All are answering. Keep going. Okay. So the correct option is peristaltic movement. The contraction and the expansion movement of the walls of alimentary canal or the food pipe is called a peristaltic movement or peristalsis. Okay. Next question. When a few drops of iodine solution are added to rice water, the solution turns blue-black in color. This indicates that rice water contains. So, iodine solution. For what test we use iodine solution? Iodine solution we use to detect the presence of starch. Iodine solution, especially in photosynthesis, we did the starch test, right? Presence of starch with the use of iodine. So, iodine we use to detect starch. So, the correct option is C, that is starch. Okay, very good. Next question. The opening and closing of the stomatal pore depends upon. The opening and closing of stomatal pore depend upon which of the following? See, stomata opens and closes by the action of, by the entry of water into the guard cells, right? When the water enters into the guard cell, okay, when water enters into the guard cell, it swells up. And what is that process called when water enters into the guard cell? That process is called endosmosis. Endosmosis. When water enters into the guard cell, that process is called endosmosis. We have learned that movement of water from a region of higher concentration to lower concentration is called osmosis through a semi-permeable membrane. That you should add. That is very important. Through a semi-permeable membrane. So here water enter into the cells, right? Water enters into the cells, that is called endosmosis. And when the water enters into the guard cell, it will swells up and the stomatal pore will be open. The stomatal pore will be open. When water leaves, okay, when water leaves, what happens? This stomatal, see here you can see when water leaves from this, what is that process called? That is exosmosis. See, when water leaves from the guard cell, it is called exosmosis. Due to exosmosis, the guard cell will, like you can see the guard cell here, the pore will close. The pore will close. See here you can see the pore will close. Now the opening and closing of the stomatal pore depends upon oxygen, temperature, water in the guard cell, concentration of carbon dioxide. Which is that? It is water in the guard cell. It depends on the water in the guard cell. And you should learn the term that is endosmosis and exosmosis. Especially osmosis is very important topic. Next question. See here, read this. Which of the following option shows the transport of oxygen to the cell correctly? See here, lungs, pulmonary vein. Okay, for this, we need to draw the structure. See, here we can represent the chambers of heart, right atrium, left atrium, right ventricle, left ventricle. Okay, right atrium, left atrium, right ventricle, left ventricle here. Now, we have to draw the tissues here, cells or tissues, then the lungs. Okay, what happens inside the lungs? When we breathe in, the amount of oxygen inside the lungs will be more. That means partial pressure of oxygen will be more. We call it as PO2, or we can call that concentration of oxygen is more inside the lungs when we breathe in. See, in that condition, the blood, okay, the blood will combine with, that hemoglobin will combine with the oxygen, and that form oxyhemoglobin. Okay, the hemoglobin will combine with oxygen to form oxyhemoglobin, and that now we can call it as oxygenated blood. So oxygenation happens. Where oxygenation happens? Oxygenation happens inside the lungs. Now, after that oxygenation, a blood vessel that carry blood to left atrium. Okay, the blood vessel that carries blood to left atrium. See, any blood vessel, okay, whatever it may be, any blood vessel that carry blood towards heart is called a vein. Okay, the blood vessel which carry blood towards heart is called a vein, and the blood vessel which carry blood away from the heart is an artery. So it depends on, see, where it carries, from where to where it carries blood. Depends on that, we can call it as vein and artery. Here it carry blood towards the heart, so it is a vein. Towards the heart will be an artery, towards the heart will be a vein, so we can call it as a pulmonary vein. Why we call it as pulmonary vein? Because it carry blood from lungs, so we call it as pulmonary vein. So pulmonary vein carries blood towards left atrium. Now see, from left atrium to left ventricle, The blood flows from left atrium to left ventricle, right? Okay, from there, the blood flows from left ventricle. From left ventricle, it will be pumped towards the tissue. Okay, so which blood vessel carry this? Which blood vessel carry this? That is aorta. Okay, aorta. So aorta carries, the main artery is called aorta. Aorta carries blood from the heart to organs. From heart to organs, it's arteries, and aorta is the main artery. Now it carries. So what kind of blood is this? This is oxygenated blood. It is oxygenated blood. So here you can see the left part of the heart. Okay, the left part of the heart carries oxygenated blood. Left part of the heart carries oxygenated. Left part of our body carries oxygenated blood. Now, from the cells, what happens? Cells utilize oxygen, right? Cells utilize oxygen and they release carbon dioxide. By cellular respiration, what will be the byproduct? That is carbon dioxide. So, the cells release carbon dioxide. Now, the oxygenated blood will convert to deoxygenated blood. The oxygenated blood is converted to deoxygenated blood. Now, that deoxygenated blood is carried by the main vein. Okay, main vein towards right atrium. Towards right atrium. So we can call it as vena cava. So it is vena cava which carry blood towards right atrium. Now from right atrium to right ventricle, the deoxygenated blood. Now it is deoxygenated blood, right? Deoxygenated blood. From right atrium to right ventricle, the deoxygenated blood pumps, and from right ventricle towards the lungs it flows. Now, which blood vessel carry that to lungs? That is, see, from heart to any other organ, from heart to outside, an artery carries. So, it is pulmonary artery. Pulmonary artery carries blood towards lungs. So, pulmonary artery carries towards lungs. Now, you see, this is what the exchange of gases, and this is what the blood vessel which carry blood from different parts. Now, see, which of the following option shows the transport of oxygen to the cell correctly? To the cell correctly. From this, which is the option? Which option is correct? From lungs to pulmonary vein carries. Pulmonary vein carries to left atrium to left ventricle, aorta and body cells. So, which is the correct option here? Okay, very good. It is option A. Option A is the correct one, where it carries blood from lungs to heart through pulmonary vein, and from heart to cells by aorta or artery. Next question. Okay. How is food transported from the phloem to the tissues according to the plant's needs? See, how is phloem transport food? Okay. See, we know that the transport of water through xylem, it happens through xylem, and the transport of food take place through phloem. And the difference between transport of water and food and xylem and phloem, through xylem and phloem, it's different. Now here, what is it? Food is transported along with water in the plant's body? No. Food is transported in only one direction like water in the plant body through xylem? No. Phloem transport food bidirectional. It is bidirectional transport. Now, food is transported from a region with low concentration to high concentration? No. Food is transported from the region where it is produced to other parts of the plant. So, which is the correct option here? The last one is correct. Food is transported from the region where it is produced to other parts of the plant. And what is that name called? There is a proper name for that, right? So, what is that name? What is that single, one word for that? So, can you please comment it? So what is the name for it? What is the name we call? That is translocation. What is that called? Translocation. So it is translocation. So what is translocation? See, the food transported from the region where it is produced to other parts of the plant is called a translocation. Next question. So let's see control and coordination chapter. What is the function of pituitary gland? What is the function of pituitary gland? To develop sex organs in male, to stimulate growth in all organs, to regulate sugar and salt levels in our body, to initiate metabolism in the body. What is the role of pituitary gland? We know that pituitary gland produces what hormone? That is growth hormone, GH, right? So that GH, what is the function of GH? To stimulate growth in all organs, to stimulate growth. That is the role of pituitary hormone, growth hormone, to stimulate growth in all hormones. Okay, next question. See, a female is suffering from an irregular menstrual cycle. The doctor prescribed her some hormonal tablets. Which option shows that the hormone she lacks in her body is from the endocrine gland? Oh, which hormone she lacks here? See, she has an irregular menstrual cycle. Irregular menstrual cycle means which of these is associated with it? Female sex hormone is associated with it, right? Female sex hormone. Which is the female sex hormone here? Yes, very good. It is estrogen. It is estrogen is the female sex hormone which take part in normal means regular menstrual flow, everything. So it is estrogen, and testosterone is the male sex hormone. Adrenaline is a stress hormone produced by adrenal gland. Thyroxine function is metabolism. So which is the correct option? That is estrogen. Next one. See, how will information travel within a neuron? See, we know that the information travels only through a single pathway. Okay, only one direction it travels. What is that direction? From dendritic end of a neuron. See, from the dendritic end of a neuron, see, from the dendritic end of a neuron here, the first impulse generation happens here. Now from this dendritic end to cell body to axon. See, cell body to axon, axon to nerve endings. See, this is the proper way of the message transmission. Now see here, how will the information travel? See, dendrite to cell body to axon, axon to nerve ending. Here what is it given? See, first you should start from dendrite, and here are two options. What is it given in this A and B? It is dendrite to cell body or dendrite to axon. The first option A is correct. So from dendritic end to cell body to axon, axon to nerve endings. That means axonal endings. That is the proper way of. Now, next question. Which of the following option shows the mechanism of the traveling of sense in our body after our nose sense a smell? See, when our nose sense a smell, see, the smell got activated. What is that receptors called? Is it gustatory receptors or olfactory receptors? Which is the one? It's olfactory receptors, right? It's olfactory receptors. So we don't want to see these two options because we know that it is olfactory receptor. The smell is associated with what kind of receptors? That is olfactory receptors. Now from this two, you see which is the correct one. Olfactory receptors to dendritic tip of a nerve cell, then axon, nerve ending, release of the signal, dendritic tip of another neuron. Here it is given olfactory receptors, dendritic tip of a nerve cell, axon, cell body. See, now we have learnt, is it possible to move or travel an impulse from axon to cell body? Is it possible? No. So it is the option A. Option A, olfactory receptors, dendritic tip of a nerve cell, axon, then nerve ending and release of the signal to the dendritic tip of another neuron. So first is the option. For A is the correct option. Next question. See, when we touch the leaves of touch me not plant, they begin to fold up and droop. How does the plant communicate the information of touch? Very important question. Very, very important question. We have learnt about nastic movements and tropic movements, right? So what is the difference between tropic movements and nastic movements? Growth related or directional movements are called tropic movements. Growth independent or it is not related with the direction, that is called non-directional movements, that are called nastic movements. Here the movement of touch me not plant is a nastic movement. Here you can see the movement of touch me not plant is a nastic movement. What happens? The plant uses electrical signals to transfer information, and the plant uses electrical and chemical signals to transfer information from cell to cell. The plant uses electrical chemical signals to transfer information from tissues to specialized cell. The plant uses electrical signal to transfer information from cell to specialized cell. So what kind of impulse is generated there? Is that only electrical? Is that only chemical, or is that electrical and chemical signals? Okay, it can't. What kind of movement is seen in touch me not plant? What kind of movement? See here, you can see the plant uses electrical and chemical signals, right? The plant uses electrical and chemical signals to transfer information from the cell to cell. So which is the correct option? Which is the correct option? Option B. The plant uses electrical chemical signals to transfer information from cell to cell in the case of touch me not plant. Next question. Yeah, very good. All are answering, and your participation, I appreciate your participation is very good. Okay. Next question. Organisms depends on hormones as well as electrical impulses for the transmission of signals from the brain to rest of the body. What can be a likely advantage of hormones over electrical impulses? What is the advantage of hormones over electrical impulses? Here we have, it is secreted by all types of cells present in the body. It is secreted by stimulated cells and reaches all cells of the body, and it relates to the target organ faster than electrical impulses, and it does not depend on an external stimulus to be generated in these cells. Which is the correct option? You can answer. Yeah, it is secreted by stimulated cells and reaches all of the body, reaches all cells of the body. See, it is secreted by stimulated cells. We know that there are target cells. That means that hormones are released through blood, right? So it reaches all the cells all over the body because there is no proper duct to for traveling of hormone. There is blood. The blood transport hormones. So here it is secreted by stimulated cells. Okay, it is secreted by stimulated cells. We know that some hormones are secreted by some specialized organs. So that is why it is written, it is secreted by stimulated cells and reaches all cells of the body because it is transported through blood. Okay, next question. Very good. It is option B. Next question. From reproduction chapter, fruits are formed from the which part of this? Okay, fruits are formed from which part of the following? We know that after fertilization, okay, in a plant, after fertilization in a flower, the ovule develops as seed and the ovary that cover the ovule develops as fruit, right? So, which is the correct option here? The fruits are formed from which part here? That is ovary. The fruits are developed from which part? That is ovary. Okay, very good. Next question. The male reproductive parts of a flower, the stamens, are collectively known as. The group of stamens are called. What is that name? That group of stamens called? It is androecium. Okay, the male it is given, right? You have learnt about anther, the part of male reproductive system, right? So here the group of stamens is called androecium. The group of stamens is called androecium. Okay. Now what about the group? See the male reproductive parts of a flower, the stamens are collectively known as. Okay, stamens are collectively known as. That is androecium. Okay, that is androecium, not anther, it is androecium. And the group of female reproductive parts, that means the group of carpels, what we call it is gynoecium. It is gynoecium. Here it is androecium and the group of female reproductive part collectively called gynoecium. Okay, so here it is A because it is male reproductive parts. It is male reproductive parts, stamens collectively called. Okay. Next question. Which of the following disease is transmitted sexually? STD, you have to write an STD here. Sexually transmitted disease from this. Chalazar, the jaundice, cholera and syphilis. Which is the sexually transmitted disease here? Sexually transmitted disease. Is it chalazar? Is it jaundice? Is it cholera or syphilis? It's syphilis, right? Syphilis. From this, syphilis is the sexually transmitted disease. STD. Next question. See the correct sequence of the organs in the male reproductive system for the transport of sperm. How the sperm transported from the site of production, where is it produced? It is produced inside the testis, right? From testis, it is carried by a duct called the vas deferens or vasa differentia we can call. From testis, it is carried by vas deferens. Okay, see here it is given testis, the sperm is carried by vas deferens, and here it is given urethra here and ureter there. You can see A and D option. Testis, vas deferens, urethra and ureter. So which is the correct option? Yes, it is option A. Why it is option A? Because urethra we have learned yesterday's class, yesterday's live class I have explained in detail about urethra. It's urinogenital duct, right? The urinogenital duct carries both sperm and urine. So here it is, the correct way it is testis, vas deferens and urethra, not ureter. It is urethra. So option A. Okay, next question. The process in which small portions of the oviduct of a woman is removed by surgical operation and the cut ends are, see here you can see which is the correct option. Here it is tubectomy, right? It is tubectomy. See, there are two surgical permanent way of contraception. Two that is different in male and female. Male it is vasectomy, cutting and tying of vas deferens, or sperm duct is vasectomy, and here it is in female what we call it as, it is tubectomy, cutting and tying of fallopian tube or oviduct is called tubectomy. Next question. See the chapter Heredity. Mental conducted his famous breeding experiments by working on the Pisum sativum, right? Pisum sativum. It is the scientific name for pea plants. Pisum sativum. Next question. In peas, pure tall is crossed with the pure short plants. Okay, those who were there in yesterday's live, they know in detail. We have explained many crosses, complicated crosses also we did. Okay, here we know that it is a simple monohybrid cross, right? What is the monohybrid cross ratio? The monohybrid cross ratio is 3:1. The phenotypic ratio is 3:1. Here what is it given? In peas, the pure tall is crossed with the pure short plant. The ratio of pure tall plants to pure short plants in the F2 generation is. What you have to find out? The ratio of pure tall plants to pure short plants. What is pure short and pure tall? Pure tall means capital T, capital T. That means homozygous. Okay, homozygous. This is the monohybrid cross ratio. Here what they ask to find the ratio in the F2 of pure tall plants to pure short plants. Here capital T, that is pure tall. It is pure tall. Now small t is pure short. Small t is pure short. Now what you have to find out? You have to find out the ratio of pure tall and pure dwarf. Here what ratio you will get? You know that F2 you will get capital T, capital small t, capital T small t and small t. So one capital T and one small t is there. So in what ratio you will get pure tall plants to pure short plants? What ratio will get? That is option C, 1:1. Okay, 1:1 is the ratio. Next question. Humans have two different sex chromosomes, X and Y. See, based on Mendel's laws, a male offspring will inherit which combination of chromosomes? See, we know the sex determination flow chart, right? Sex determination flow chart. The mother, from the mother, there are a pair of X chromosomes are there. In father, there will be XY. Two types of X chromosome will be there. Here it is X, one type only will be there as gametes. Here two type of gametes will be produced. What are the two types? That is X and Y. Now the gender of the child, okay, the gender of the child depends on which chromosome is coming from father. Which chromosome is coming from father? If it is X chromosome, it will be XX, that will be a girl. If it is Y chromosome, that will be XY and that will be a boy. Now, what is the question here? Humans have two different sex chromosomes, X and Y. Based on Mendel's laws, a male offspring will inherit which combination of chromosomes? One X from mother and another Y from father. So which is that? A combination of X and Y chromosomes from either of its parents. Okay, a combination of X and Y chromosomes from either of its parents. So you have to learn the flowchart of sex determination. You can expect a question from this. Okay, next question. Based on the cross in humans, if gene B gives brown eyes, okay, capital B is given here. The gene capital B gives brown eyes. So we can write here in humans, brown eye color is dominant. Okay, brown eye color is dominant. Capital B is brown eyes. Okay, it is brown. Now, small b, that is dominant over small b is blue eyes. Okay, it is blue eyes. Now, what will be the color of the eyes of the person having a combination of capital B, small b, and capital B, capital B. We know that capital B is dominant, right? Capital B is dominant. So here we have capital B is brown, and we can write capital B, small b also brown, right? Capital B, small b also brown. And here what is the question? Capital B and capital B. So what is the correct answer here? It is option A. Both are brown here. Brown. 1 and 2 is brown. Okay. Now next question. See, what is the probability that the male progeny will be a boy? What is the chance of there is a boy or a girl in a, like we have learnt about the sex determination chart, okay? What is the probability? What is the probability? That is the possibility of having a boy is 50% and that of girl is 50%. Half the chance is there, like equal chance is there. Okay, now we have to wind up the session. Before that, I would like to call the other science teachers, like we have Sudhi sir and Tanya sir, will call them to wish.
So, good evening children. So, hope you enjoyed the live session, right? So, complete year you were with us. We have taken the offline classes, sometimes online classes, Target 100, YouTube sessions, and our videos in the portal also. So, hope you have enjoyed the session very well, and the full academic year also with all the brilliant team. So, we all wish you a very bright future and then a very great success in your examinations. Okay, children? So, ma'am?
Yeah. All the best, students.
Together?
All the best. All the best, dear students. All the best.
Right. Okay? So, now it is almost 5 o'clock. So, immediately take a break. Okay, children? Take a break of 15-20 minutes or half an hour. Again, just go for a refreshment and then sit with your last minute tips. Okay, children? Thank you. Bye-bye. And see you again in grade 11 with the same energy. Bye.
Bye. All the best.